Hi everyone, welcome to Vedantu JEE English. I'm Diksha Kaushal, your chemistry master teacher, and I hope so you all are doing good and your preparation is going really great because we are just 1.5 months, you can say, away from JEE mains, and I really hope so that you're practicing also. You are practicing the previous year questions and the questions related to the previous year questions as well. Right, so I saw the previous playlist of chemistry on this channel, right? So all the other chapters we have already completed on this channel, but because students were demanding haloalkanes and haloarenes also, so I have decided that I'll take, after biomolecules, I'll take haloalkanes and haloarenes on this channel on Friday, right? Okay, so that was specially on your demand, right? And after that, I'll take up hydrocarbons. Maybe I'll talk to you guys on my Telegram channel, that is Diksha Kaushal Chemistry Official, or on Vedantu JEE English, and then we can decide that which is the next chapter you want me to do. And I want you guys to also write it down in the comment section, and I'll pick up the chapters that are common, right, that you all are asking for, right? So I'll pick up those chapters, yes, on priority. Okay, everybody, so today we are going to do biomolecules. Let me know in the chat box if we are ready to start that or not. Should I start the session or not? Very good evening, very good evening. Yes. Okay. So, shall we start the class or not? Everybody in the chat box, shall we start the class or not? Okay. So, biomolecules is basically a very simple chapter if we talk about NEET aspirants, but when we talk about JEE aspirants, right, they find it little bit difficult. The reason is because for NEET aspirants, biomolecules is also there in bio, right? So for them it is very easy. They're like, okay, this is a repetition only, we just have to add on some structures here. But when we talk about JEE aspirants, they have never studied bio, maybe in 9th and 10th class they have studied, but something like this becomes very difficult. But actually this is not a bio chapter, this is a biochemistry, right? So very easy structures we will talk about. There are DNA, RNA, nucleotides, very predictable questions we will see. And today we will also see the previous year questions of JEE mains and JEE advanced. Okay. Yes, okay, so green hearts in the chat box, everybody, shall we start this? Now, starting with what we are going to study in biomolecules. Firstly, let us see what we are going to study in biomolecules. So, biomolecules, firstly, we are going to talk about the carbohydrates, right? Carbohydrates, see, whenever we eat, wheat, which thing? Wheat, like maybe wheat, right? Wheat, rice, all the things have carbohydrates, right? Sugar, right, that is also a carbohydrate. So basically we are going to talk about glucose, fructose, maltose, sucrose, all these things we are going to talk about that are under carbohydrates. In detail we will talk about glucose, right? The reactions of glucose are also asked so many times, right? Next thing is, after carbohydrates we will jump to proteins, right? Then you have proteins in your syllabus, right? Then you have what is DNA, RNA, the difference here. Then we also have vitamins, right? So basically this is your full chapter that we are going to do, right? Maximum the structures will be there in the carbohydrates, right? After that, proteins is amino acids. We will talk about amino acids, acidic, basic, neutral amino acids, a chart on that. Then DNA, RNA, the difference, what are these made up of? Then vitamins. Vitamins is basically a theory part, right, related to the theory of vitamins and enzymes also. So we'll talk about that also, right? Okay, so starting with the carbohydrates, okay? So we are starting with carbohydrates now. Let us start with carbohydrates. So carbohydrate is everywhere. As you can see, rice, bread, wheat, roti, right? Everywhere there is carbohydrates, right? So especially in Indian diet. In a vegetarian diet, though, it's too much, right? So now, carbohydrates may be defined as optically active. We will talk about why they are optically active. Optically active polyhydroxy. Hydroxy means OH group are present here, right? Poly means many OH group are present here. Aldehydes or ketones, that means there will be either one aldehyde group, that is CHO, or ketonic group, that is C double bond O, right? Or the compounds which produce such units on hydrolysis. Either they will have aldehyde, ketone and polyhydroxy, or after hydrolysis they will give those kind of products which have this kind of thing, that are optically active polyhydroxy, aldehyde or ketone. These are named as carbohydrates. So some of, just give me a second, I forgot to wear my specs, just give me a second. I don't want to strain my eyes, you know. Yes, I guess students are very less interested in biomolecules. JEE aspirants are already like, either they feel this is very simple or they feel this is very difficult, I don't want to study this only, right? But this is the most scoring chapter, I would say. Just see this lecture and you will be able to answer everything in the exam, right? So some of the carbohydrates which are sweet in taste, like we eat sugar, right? Called sugars, most common sugar used in our home is sucrose, that we use in our home, whereas the sugar present in milk is lactose, right? In milk there is lactose present, right? Lactose is made up of galactose, so galactose and lactose both are present in milk, right? So carbohydrates are also called saccharides. This is their name, that is saccharides. That is why we will talk about monosaccharides, disaccharides, trisaccharides, oligosaccharides, polysaccharides. So let us see this classification, right? What is this classification of carbohydrates? So based on the hydrolysis, what they are giving. If after hydrolysis they are giving nothing new, right, cannot be hydrolyzed further to give simpler unit of polyhydroxyaldehyde, that means if I hydrolyze glucose, it is not going to give me some new compounds, right? Some new saccharides it is going to give. No. So that is why it is a monosaccharide, right? If you talk about disaccharides, wait a minute, in oligosaccharides you will have disaccharides. Basically, oligosaccharides means we are talking about from monosaccharides that yields 2 to 10, right? 2 to 10 units. That means either on hydrolysis it is giving us 2 monosaccharides, or it is giving us 3 or 4 or 5, 6, 7, 8, 9 or 10. Right? If it is giving us 2 to 10 monosaccharides unit on hydrolysis, then that is called oligosaccharides. In our syllabus, we will study monosaccharides and disaccharides. Disaccharides means on hydrolysis that are going to give us 2 monosaccharides, right? Okay, so that is your disaccharides, that is under oligosaccharides. Polysaccharides are, they are giving us poly, means many, like we can't even count. After 10, if it is giving more than 10 monosaccharides, that is called a large number of monosaccharides, that is called polysaccharides, right? We will study few polysaccharides also, right? Okay, like cellulose we will talk about, starch, right? All these things we will, glycogen, right? These things we will talk about, right? So first thing is, if you talk about monosaccharides, monosaccharides are 3 things in our life, right? We have 3 monosaccharides, not in our life, but here we have 3 monosaccharides mainly, that is glucose, then you have fructose, then you have galactose, then you have galactose. These are the 3 monosaccharides that we have, right? So firstly, we are going to talk about glucose, right? Glucose is in like much detail in your syllabus. You have even the reactions of glucose. So we are going to see the glucose in like too much detail, right? Okay, yes. Wait a minute, let me see. Oh, I don't even know how to do this. Just give me a minute. Okay. Hit and trial. Okay. I think this much is fine, right? Okay. I think, wait a minute. Is this blurry? No. I think now it's fine, right? Okay. Is this fine now? Everybody in the chat box, is this fine now? Everybody, is this fine now? I don't know whether I'm feeling it's too much hot here now. Yes, guys, please talk, please say something, right? Yes, it's better. Okay. So now let us see. Basically, you have three monosaccharides: glucose, fructose, and galactose. Glucose, in detail, we have even the reactions we have in our syllabus, right? How it was, how the structure was predicted by different reactions, right? So let us see this thing. They are saying basically you have two kind of monosaccharides. One will have maybe aldehyde group, other will have ketonic group. If you talk about glucose, that is having aldehydic group. If you talk about galactose, that is having aldehydic group. Right? If you talk about ketonic group, the one monosaccharides which has ketonic group, that is fructose. That is called fructose. Fructose is the example of the one monosaccharides which has ketonic group in it. Right. So if you talk about aldehydic group, that is aldose. Aldose means aldehyde, ose means carbohydrate, right? So ketonic, ket, right, and ose means carbohydrate, right? So this is aldose and this is ketose. The example of ketose and aldose I have already written here. Next, we have different types of monosaccharides. Now, in general, they are just stating the general name of this. Like they are saying that if you have 3 carbon, that means tri. Ose is for carbohydrate only. Now, if that has aldehyde, that will be aldotriose. If it has ketone, that will be ketotriose. Similarly, 4 means tetraose, 5 means pentose, 6 means hexose, and 7 means heptose. Right? And if you have aldehyde, that is aldotetrose, aldopentose, aldohexose, aldopentose. Sorry, aldose here should be heptose. Ketotetrose, ketopentose, ketohexose, ketoheptose. Right? So now tell me one thing. In all the glucose, fructose, and even the galactose, you have 6 number of carbons. So that is the reason these are termed as this thing, right? So if you talk about glucose, then glucose or galactose, these are the example of aldohexose, right? Ketohexose, that is the example is fructose. Fructose is the example of ketohexose, right? So because here you have 6 number of carbons in all the cases, whether it's glucose, galactose or fructose. Glucose and galactose has aldehydic group, right? There is just minor difference between glucose and galactose, but fructose that has ketonic group in it, right? Okay, yes, everybody. Now, next thing is preparation of glucose. And students, now I am going to tell you 6-7 reactions here. From there, you will see yourself in 2024, the questions has been asked, right? So if in 2024, the question has been asked from this particular section, that means in 2025, also you can expect the same kind of questions, right? Okay, so now everybody focus on this, right? Till here, so we were doing this base, right? They are not going to ask you these kind of questions, right? From here, they will ask you the questions, right? Okay. So now, when we talk about the glucose, the quality of glucose is that how it is prepared. So now we have a disaccharide, that is a disaccharide. We will also learn the structure of sucrose. Basically, disaccharides are made up of monosaccharides, and glucose is made up of 2 monosaccharides, that is fructose and glucose. Right? Sorry, sucrose is made up of 2 monosaccharides, that is glucose and fructose. That means glucose and fructose will form sucrose. That is why the reverse reaction happens. When we add water into sucrose, it will give us glucose and fructose, right? So that is the preparation of glucose, that when you have sucrose, right? When you have sucrose, then what you will do, you will add water into it and you will get glucose out of that, right? So sucrose is usually in our sugar, there is sucrose. So when we add water into it, we get glucose and fructose from that, right? So now H2SO4, now this is important, that if sucrose is boiled with dilute HCl or H2SO4, right, it needs acidic medium here. If it is boiled with dilute HCl and H2SO4 in alcoholic solution, glucose and fructose are obtained in equal amounts, right? They are obtained in equal amounts, okay? They are obtained in equal amounts, right? And sucrose we will talk in detail. It is an invert sugar. Why it is an invert sugar? We will talk everything about that, right? When it comes to disaccharides, when we will study disaccharides, we will talk about sucrose in detail. Now, next is from starch. How from starch? Because the monomeric, now you know what are polymers. Polymer means, for example, if n units of some compound that will combine and it will make something of that compound, and n. That means when you have a polymer, that means one unit is getting repeated again and again, and we don't know how many times it is being repeated. That is called a polymer. In the same way, we have polysaccharides, that is starch. That is a polysaccharide. Polysaccharide. So now these polysaccharides, starch is made up of glucose only, right? We will also talk about starch and cellulose in detail when we will study polysaccharides, right? So these polysaccharides are made up of only glucose units. That is why when you hydrolyze this to n amount, like infinite water you are adding here, what will happen? It will break down into glucose units, right? N number of, infinite number of glucose units you will get, because infinite number of glucose units were combining to form that starch. It's just a very simple thing. For example, you are sitting on a bench, right? You are sitting on a bench and two tables you have joined, right? Two tables you have joined. So now when you want to break these two tables, what you will do? You will break it like this, right? This is a disaccharides converted into two monosaccharides. For example, you have like n number of monosaccharides unit here, right? N number of monosaccharides unit here, right? So those many units will be replaced here. Those many units will break here, right? Like this. Those many units will break like this. Are you able to understand this? Those many units will break like this. Okay, so simple thing. Okay, yes. Okay, everybody, that was simple, right? So from starch and sucrose, glucose can be made. Then let us talk about the structure of glucose. Now it was predicted to be this kind of structure, right? So I am not going into Fischer structure, like exactly where OH is, where H is, whether it's on right or left side, that we will study. But before that, how can we predict that it has one aldehyde group, it has 6 carbons, then it has 5 OH groups, out of which 4 OH groups are secondary and 1 OH group is primary. How can we predict all of these things? Let us talk about the structure of glucose. What were the reactions that predicted that it has this structure, and all the reactions are important. First is glucose is a aldohexose and is known as dextrose. Do you know why it is known as dextrose? It is known as dextrose because it rotates the plane polarized light towards left or right. Just remember dr, right? Just remember dr, or you can say rd, whatever you want to remember. Just remember rd, right? R means that is your right side and D means dextrose, right? So when you rotate the plane polarized light towards right, that is called dextrorotatory. So glucose is dextrorotatory. It's not levorotatory, and dextro and levo are experimental things that is defined experimentally. So glucose is dextrorotatory. So always whenever you see glucose, you will have this positive sign, or it is represented by this small d, right? It is represented by this small d I am talking about, not small, not capital D. Capital D and small d are entirely different, right? Small d and capital D, small d and capital small d and small l represents basically two things. That is, for example, you have a polarized light, right? So when you polarize the light and you have a compound here, when you pass this polarized light through this compound, if that light is rotated towards right, that compound will be dextro. If that is rotated towards left, that compound will be levo. If that light is not rotated anywhere, that means this compound is optically inactive. And optically inactive compounds, we already said in the first line of today's lecture that these compounds are optically active. That means either they will be dextro or they will be levo, right? Okay, understood? Very good. Levo will rotate it on the left side. Now, let us see another thing is, it is monomer of many of larger carbohydrates, right? Namely starch. As I told you, starch also has a monomer glucose, right? It is probably the most abundant organic compound on the earth. Now let us see firstly the molecular formula, right? By NMR spectroscopies, it was defined to be C6H12O6. Now the question is, how can you say that it has 6 carbons, right? What was the reason that it has only, how can you say that it does not have any branching? You are saying that it has 6 carbons, it could be like this. It also can be like this, okay? It also can be like this. Why you are saying that it is a straight chain? Right? Why you're saying there is no branching here? So for that, they reacted this particular substance, that is glucose, with HI. This question has also been asked in your JEE Mains 2024, right? So with HI, they reacted and heated up. Then after that, you got N-hexane. N-hexane means that there must be a straight chain without any branching, right? So connected carbons are connected in a straight chain. This told us that carbons are connected in a straight chain and there is no branching involved here. There is no branching here. In this glucose structure, there is no branching, right? This is because of the reaction with HI and with prolonged heating, you got N-hexane. That is the reason we today know that it is a straight chain without any branching. Now, next question is, you have defined that it is a straight chain, but how you can say that it has ketonic group, or let's say, how can you say that it has a carbonyl group, right? Forget about ketonic and aldehydic. How can you say that it has a carbonyl group? It can be aldehyde or ketone. So, let us see the reactions of aldehyde and ketones that we have done in aldehydes and ketones, right? So, let us see this. We know that these two reactions, that if you have a carbonyl group, right, that reacts with NH2OH, what it will give you? Everybody, this we have done, what it will give you, right? Firstly, you will replace this particular thing. This oxygen and this H2 will be eliminated and you will have C double bond. This is N, this is OH. This kind of thing will be formed. If it is a carbonyl group of aldehyde or ketone, then with NH2OH you will have this kind of compound, right? That means oxime will be formed here, right? Now, can I say that if glucose reacts with NH2OH, I have this same kind of compound that I was expecting from a ketonic or a aldehydic group? That means yes, it has a aldehydic or a ketonic group. It has a carbonyl group here. Then there is one more reaction with HCN. Now, for example, you have C double bond O. This is plus HCN. We know that here H is positive, Cn is negative. Because of that, this is partially positive, this is partially negative. This Cn negative will attack here and electrons will jump here, and hence what you will have? Okay, you will have the formation of a cyanohydrin. So can we see that same thing here? This is C, this is O negative, and here you have three things attached. One is Cn. There are two bonds already, right? One is Cn, and to this O negative we have the attack of H positive. So basically a cyanohydrin is formed, and here oxime is formed. So the formation of these two things, that is oxime and cyanohydrin, that tells us that definitely there is a ketonic or aldehydic group present here, right? That definitely there is a ketonic or aldehydic group present here. So we can say carbonyl group is present in glucose. Now we are sure about that, right? That I don't know whether it's yes, capital D we will talk about, okay? We will talk about capital D, capital L, everything in today's lecture, right? Okay. Now, next thing is the fourth thing is, this question also is a very repeated question of 2024, right? A very famous question, right? So that's why I'm saying that. Now they are saying that how can you say that it's a aldehyde or a ketone, right? What is the reaction of confirming that definitely this is a aldehyde, definitely this is a ketone, right? Then what we do? We reacted this with bromine water, right? So with the bromine water, what we got? This is a mild oxidizing agent, and what we got here? From glucose, we got, also the name is very important, that we got gluconic acid. With bromine water, we got gluconic acid. What is gluconic acid? This CHO is oxidized to COOH, right? This is not oxidized. See, why it is called a mild oxidizing agent? We know that if you have alcohol, you will convert it into aldehyde or ketone, then to basically aldehyde only, then you will convert into carboxylic acid if it is a mild oxidizing agent, right? If it's a strong oxidizing agent. If you want to convert alcohol to carboxylic directly, you need strong oxidizing agent, isn't it? If you want to convert aldehyde to carboxylic, you need mild oxidizing agent. So now this alcoholic group is not converted to anything. This alcoholic group is as it is, but the aldehydic group is converted to COH. That means after using a mild oxidizing agent, when you use a mild oxidizing agent, then CHO group is converted to COH group. That is called gluconic acid. This confirms that we have the presence of, aldehydic group. Otherwise, if it was a ketonic group so will not, see, if you talk about ketone, this is ketone. Can you convert a ketone to this carboxylic acid by using some oxidizing agent? Have we seen this reaction anywhere? That with mild oxidizing agent, you can convert ketone to carboxylic. No, ketone was not showing any reaction, right? We can convert 2-degree alcohol to ketone. But ketone is not further oxidized to carboxylic acid. Aldehyde was further oxidized to aldehyde, right? So that is the reason this is not converted. So we can confirm that this is not a ketone. This is a aldehydic group. Proves the presence of aldehydic group, as ketones do not oxidize to acids in presence of bromine water, right? Ketone in presence of, forget about bromine water, with any mild oxidizing agent, they will not get oxidized to carboxylic acid. Right? Okay. Yes, the lesson will be over today. Don't worry about that. Are you able to just focus on, are you able to understand this or not? Right? That is the main thing for you. Right? Understood that what is the use of this reaction? After this, we know that, okay, this is a carbonyl, it is a aldehydic group, that we have confirmed. Now let us see, how can you say that it has alcohols, right? Who told you that there is presence of alcoholic group, hydroxy group is present here? Now for that, we reacted this with acid anhydride in presence of pyridine, right? What is this acid anhydride? It is CH3, C double bond O, O, C double bond O, CH3, right? Okay, it is also already written here. So this is the acid anhydride, right? So we reacted this with acid anhydride in presence of pyridine. Now guys, tell me one thing. From here we know that this compound will break, right? And this will attach on this particular thing. So basically what will happen here, this is your OH group. The hydrogen here will be replaced by the CH3CO group, right? Okay, the hydrogen will be replaced by this particular group. Okay, hydrogen is replaced, you can write it here, hydrogen is replaced by CH3 C double bond O. Hydrogen, if it is replaced, see, if hydrogen is an alcoholic, then definitely it will be replaced by CH3 C double bond O, right? So that is the reason this hydrogen is replaced by CH3CO, right? This hydrogen is replaced by CH3COO. Then we can confirm that there is a presence of alcoholic group also. Alcoholic group is also present here, right? Because the hydrogens are being replaced by CH3CO, that is acetyl group, right? So here we can say that acetylation of glucose with acetic anhydride gives glucose pentacetate, which confirms the presence of 5 OH group, because 5 places, this is 4 and this is 5th place. At 5 places, you have the replacement of OH group. That is the reason here we can say that 5 OH groups are present. It exists as stable compound. 5 OH groups should be attached to different carbon atoms, right? Why they are saying that 5 OH groups should be attached to different carbon atoms? The reason is that if you talk about carbon, it has 2 OH groups on the same position. This is not a stable condition. So definitely these 5 OH groups are attached to different carbon atoms. That is why now we are confirmed that total it has 6 carbons, right? Total it has 6 carbons. That means 1, 2, 3, 4, 5, 6. One is aldehyde group, right? Other we know that are having OH. Right, so if here you have OH, so this will be CH2OH, no, it will be CHOH, 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 here also CHOH, and this is CH2OH, right? Still, to confirm that, because here we can see one thing, that it is having how many, this is, this OH is connected to that carbon, which is further connected to 2 carbons, so here's 2 degree. And here you have 1 degree alcohol. So alcohol are also of 2 types. Also, this also we need to confirm. How can we confirm that? Using strong. Do you remember this thing? Do you remember this thing or not, everybody? Do you remember this thing? When I was teaching you aldehyde and ketones, I taught you this thing, that if you have 1 degree alcohol, on strong oxidizing agent, it will be converted to COH. But if you have 2 degree alcohol, it will be converted to ketone, right? It will be converted to ketone. Let us see now with strong oxidizing agent what will happen here, right? So now what we are using a very strong oxidizing agent here, right? Very strong oxidizing agent. Let us see what is going to happen here, right? So with a strong oxidizing agent like concentrated HNO3, what we observed that definitely CHO group is aldehydic will be converted to COH, but with strong oxidizing agent, we also observed one thing, that the primary alcohol is converted to COOH. When these two, CHO and CH2, this is also converted, that means definitely it is a 1 degree alcohol. It is a primary alcohol. Now this is also confirmed from this side, right? That it is a primary alcohol. Now the name is important, that this thing, when you add concentrated HNO3, which is a good oxidizing agent, you will get saccharic acid. When both CHO and CH2OH, that is primary alcoholic, is converted to COH, right? And now what is mentioned here? This is gluconic acid. And from where gluconic acid was formed? This was formed from glucose. When you add bromine water, remember when you add bromine water to glucose, you had gluconic acid, right? That means they are saying that you are doing one step oxidation, then further you are doing oxidation, then also you will get a saccharic acid, right? Okay. Students, tell me one thing, is that thing clear to you, right? How we from nothing, now we know that there are 5 OH groups, there are 4 2 degree, 1 primary, 1 CHO group, right? Is that thing clear to everybody, right? That with mild oxidizing agent like bromine water, it is giving you gluconic acid. With strong oxidizing agent, directly it is giving you saccharic acid, right? Okay. Yes, Bacha, everybody in the chat box, is that clear or not? Is that clear or not? Is that clear or not to everybody? Is that clear or not? Right, so glucose is concluded to have 5 alcoholic group, 1 aldehydic group, right? That is why polyhydroxy aldehyde or ketone we talk about. It all on different carbons. As the structure is stable, the structure of the glucose is assumed to be this one, right? Okay, so now we are going to, in front of you only, everybody, I want you guys to also draw these structures yourself, right? So now the important part has started. Now we have done the reactions. First question, predictable question that can be asked, that is from the reactions of glucose, right? Different reactions of glucose. They can ask you any question like adding bromine water, adding concentrated HNO3, adding anhydride, like acetic anhydride, adding maybe HI. What other different products can be formed, right? So all reactions are important to you, right? So now we are going to draw the structures, right? Defining that on which side you will have OH, on which side you will have hydrogen, right? So basically we know one thing, that this glucose is basically, we know one thing, that it is having CHO group and it is having CH2OH group, right? So I am going to firstly write that thing here. It is having CH2OH group, right? I have written that thing. How many carbons we are still left with? How many carbons we are still left with? We are left with 4 carbons. 1, right? 1, then you have 2, then you have 3, then you have 4th. So these 4 carbons we are left with. Now I'll tell you a simple trick for this one, right? Always remember that the third carbon, on the third carbon, OH is on the left side, others OH is on the right side, right? So this is first, this is second, this is third, this is fourth, this is fifth, this is sixth. On the third carbon, I am saying the OH is on the left side, right? OH is on the left side, that means this side, right? Others you have OH on the right side only, that means this side, right? That means this side. So this is how you draw the structure of glucose. Okay, guys? Okay? On just third carbon, you can write it somewhere, right? These are the basic things that you need to know if you want to actually score marks in biomolecules. Otherwise, without knowing these structures, forget about biomolecules. You won't be able to understand. So, I am giving you simple tricks here, right? Okay? Yes, everybody. So, now here you have, this is your glucose. Now, here just write down one thing. Okay, make a cloud here. Wherever I am making these clouds, that means I am giving you some important tricks here, right? So on glucose, we know that there is one aldehyde, there is one CH2OH, right? That too we know. Here it doesn't matter OH is on the right or left side, it's primary. Here the configuration will matter on the second, third, fourth. Let's write down one thing. Third carbon, OH should be OH on left side, OH on left side. Other carbons, OH on right side. Okay, I think that's it. I think that is enough for you, right? Okay. I hope so. From this, you will be able to make any structure, right? So now once you are clear on this structure, from this structure only, we are going to create other structures as well. From this structure only. Even fructose, even galactose, even sucrose, even maltose, lactose, all the structures if you know the structure of glucose, you will be able to answer all the structures, right? Okay. Okay, ma'am, please explain again. See, we know that there are 5 OH groups, out of which one is primary, others are secondary, and there is one CHO. Now, just mark this line you have on the 6th position CH2OH, on the 1st position you have CHO. After this, you need to remember the problem that students face is, ma'am, which OH is on the left side, which OH is on the right side. So the third OH is on the left side, all the other OH are on the right side in the structure of glucose, right? Okay, are you able to draw this structure? Just remember this thing, third carbon on left side, that's it. You don't have to mug up this full structure, copy paste in your head, ma'am, I am forgetting this again and again. You don't have to do that, just third carbon OH is on the left side, that's it. Okay, now from this, as you can see, this was the structure, right? Now, for glucose, OH is on the third, OH is on the left side, third OH is on the left side, third OH is on the left side. Other things are same only. Tell me one thing, if you want to make gluconic acid, in gluconic acid, only one COH group you have. So this aldehyde is converted to COH group. In saccharic acid, you have two COH group. That means this is converted to COH group. This will be COH group. Wait a minute. This will be COOH group. Okay. This will be COOH. Right. So this is COH and this is also COH. That is your saccharic acid. Okay. So gluconic acid also you know, saccharic acid now you also know. Any structure can be asked to you. Any structure can be asked to you. Right. Next thing is talking about the stereochemistry of this structure. Stereochemistry, we will talk about small d, small l, capital D, capital L. Now, if you talk about small d and small l, as I told you, that you have a plane polarized light like this, right? You have a plane polarized light like this, right? This is your plane polarized light. And there is one compound, I don't know which compound, it can be any compound, right? I am passing this plane polarized light. So basically, how I got this plane polarized light? Firstly, I had placed unpolarized light only, right? That was reflecting in all the directions. After passing it through Nicol prism, right? I got plane polarized light. Now, if after passing it through plane polarized light, I will get three things. Either it will be rotated to right side, either it will be rotated to left side, either there will be no rotation. So now if it is rotated to right side, that is called, right is called dextro. It is represented by small d or plus sign. Now if you talk about levo is basically left side, right? If it is left side, right, this is L and it is represented by negative. If it is not rotated, that is called optically inactive, right? Okay, so that is the theory behind what is optically active, inactive, and small d and small l. You can just remember this thing by this simple thing that I am writing here is dr. Diksha ma'am is always right. Diksha ma'am right. Your Diksha ma'am is always right. Right? So this is dr. You can remember this by dr. D means this I will use everywhere. Right? Even this dr will be used throughout this biomolecules. You will always see D is somewhat related to right side. D is somewhat related to right side. Here also dextro is rotated to right side, related to right side. So this D is called dextro, and here you will have right side. Here you will have right side. Okay? Here you will have right side. Okay? Yes, very, very good evening. Very, very good evening. Right? So that is your small d and small l. So if you talk about, ma'am, what is capital D and capital? This thing you will see experimentally only. I tell you that glucose is dextro-rotatory. Fructose is levo-rotatory. Okay. So glucose is dextro only. Right? That is small d and it is positive only. That is glucose. It can never be levo. It is defined experimentally. Right? But if you talk about, ma'am, what is this capital D, capital L? It's also very simple. Right? See, you will see the last chiral carbon, you will see, in the last chiral carbon of any species, if you have OH, again the same Dr. If you have OH on right side, that is called capital D. If OH is on the left side, that is called capital L. So now this again you can just remember this by this is R and this is capital D. Just remember this by Dr again. I told you this Dr somehow will be related, right? Okay, everywhere we will see Dr. Okay, so now here it is capital D and on the right side. So as you can see here, OH is on the right side, that is why it is called capital D glyceraldehyde. Now, if you talk about this thing, it is on the left side, here it is called capital L glyceraldehyde. So what you need to see? You need to see the last chiral carbon, right? From the down, you need to see the last chiral carbon that it has. Now, those students who don't know what is a chiral carbon is the one in which all the 4 groups are different. If you talk about how many chiral carbon in glucose, how many chiral carbon you can observe here? How many chiral carbon, guys? So this is, I am representing chiral carbon by this star. Okay, I am representing chiral carbon by this star. So now it is, this whole group is different, this is different, these two are different, so it is definitely a chiral carbon. This is again a chiral carbon, again a chiral carbon, this is also a chiral carbon. Here you have 2 hydrogens which is same, and here you have C double bond O, H, and again this group. So 2 double bond O means you have 2 oxygens. Okay, this is how we like assume it, imagine it, right? Double bond means you have 2 oxygens. So 2 groups are same only, that means it is not a chiral carbon. So in glucose you have 4 chiral carbons. Okay, understood? Yes, okay. Now, next is, I think that this we have done. This also we have done. Okay. Failure of state chain. Now, we will start moving towards the pyranose and furanose structures, right? Why we see this kind of cyclic structure of glucose, right? There is failure and there is also reason behind that because of 2 reasons, right? 2 experiments. The state chain structures fails to explain the following properties represented by glucose. Glucose do not show, very, very important, 2,4-DNP test. We are saying, if you are saying that it has a aldehydic group, in aldehyde and ketones, ma'am, we have seen that 2,4-DNP test, it was showing. It was showing the Schiff's base test also. It was showing reaction with NaHSO3 also. Right? That was the duty of glucose. That was the function of aldehyde and ketone also. Right? That means this carbonyl group is there because this carbon, see, very simple thing. Sometimes you are like, I want to crack this exam, I will have AIR1. Sometimes you are so demotivated in life. It doesn't mean that your soul has changed or your everything has changed. It just means sometimes you are motivated, sometimes you are demotivated. Similarly with glucose, sometimes it is in the open chain structure. At that, sometimes it is showing some of the reactions of aldehyde and ketones, especially aldehyde, I would say. Right? But sometimes it is in a closed structure. In that case, it is not showing the reactions. And these reactions are 2,4-DNP, Schiff's base, NaHSO3. They will simply ask you, what are the reactions that are not shown by glucose? The reason for that, we predicted that the open chain structure is a failure. There is one more structure that is similar to this, which is a closed structure from this open only. The pentaacetate of glucose doesn't react with NH2OH to form oxime. They are saying the pentaacetate. That means this thing that we have talked about, this thing they are saying, this pentaacetate will not further react with NH4OH. There is no reaction. Right, to form the oxime. Oxime means this thing. Oxime means this thing that we were talking about. This thing, this is oxime. Right, so that simply means that CHO group is now somewhere hidden. Right, so the state chain on direct reaction forms oxime cyclic structure. doesn't, both these observations indicate absence of free CHO group. That means this CHO group is not free, right? It is not free, right? So that means the absence of free CHO group is there. Now we will talk about how does this happen, right? What was the reason for this thing, right? So I'm just going to copy paste that slide and I'll show you how to make the structures, okay? Okay. My duty is not just to show you the structures, right? My duty is to show you that how to make those structures yourself, right? So exactly, I think till now you are able to draw this glucose structure, right? Okay. From here we will define that what is alpha and what is beta based on the cyclic structures, okay? Based on the cyclic structures we will define what is alpha glucose, what is beta glucose. That is going to play a very important role when we will talk about disaccharides, right? So now let us see this thing here, right? Okay, yes. Now let us see this thing here, how to draw the other structure, very important. So exactly what will happen here, you will have this, I am showing this by red pen only, right? This fifth carbon is going to, the oxygen of this fifth carbon is going to attack on this carbon, right? Basically, I am going to just write it like in an open form. This is basically OH, right? This is OH and this is C double bond O and this is H here. So what will happen? This oxygen is going to attack on this carbon and what you will have in the end? What you will have in the end? What you will have in the end? Wait a minute. Let me see. So this CH2OH in the end is going to stay as it is, right? Now the fifth carbon we have, draw these 4 lines here. 1, 2, 3, right? And this is 4. Now let us see what is the change that is going to occur here. What is the change that we will observe here? Right, this is CH2OH. This hydrogen is already present here. Right, this oxygen is going to make a bond with this carbon that is on the first position. So this is your first carbon, this is second, this is third, this is fourth, this is fifth, this is sixth. So that means on the fifth position you have this formation. So basically it will be like this from first to fifth. So this is your first one, right, and this is your fifth, right? They are going to make a cyclic formation here. And here we will draw this oxygen, right? This is the oxygen that is making a bond with that OH, right? This is the oxygen that is making a bond. Now, very important thing I'm going to talk about here. This fourth carbon is going to stay as it is. This is OH and this is H. Third is going to stay as it is. This is H and this is OH. Then this second is going to stay as it is. This is OH and this is H. But on the first carbon, there are 2 things that will happen here, right? What will happen that this hydrogen here, it will, this pi bond will shift here and the hydrogen is going to shift here and that is going to form a COH bond here, right? This hydrogen is going to shift here, the electrons are going to jump here, so it will form O negative and H positive, it is going to form OH bond here. That means a new hydroxyl group that you will see here, right? Are you able to understand this thing, how this happened? Fifth carbon, oxygen of fifth carbon will react on the carbon of this one, right? Okay, that is how this reaction is going to happen, and that means you will have one new OH here, right? Okay, can I draw this OH with some other pen, right? Let us draw this OH with this blue pen, right? That is a new OH that you will have. Now, this first carbon, now this is not the first carbon, right? I have drawn a specific, wait a minute. I have drawn it specifically here, right? So that is why it is formed here. Now I'm going to copy paste this slide here and I'll define that what is your alpha and what is your beta, right? Okay, I'm going to now define that what is your alpha and what is your beta, right? Now here, if OH is on the right side and H is on the left, because here you will have hydrogen and OH only, no? So if OH is on the right side and hydrogen is on the left side, in that case you can see that this is alpha glucose. This is alpha glucose. But if you say that the OH is on the left side and H is on the right side, in this case you can say that this is beta glucose. This is beta glucose. Okay, this is beta glucose. So again, alpha is on the right side. Okay, yes students, I hope so. Now you know that what is the difference. So it is the definition of alpha and beta glucose is that the first carbon, now here you had only 4 chiral carbon. Now students, now what you have, one cyclic formation you have and you have 4 chiral carbons, but here very important thing that the first carbon, here third carbon, the OH is on the left side. But the first carbon will define that whether it is alpha or it is beta, right? Okay, everybody. Okay, everybody, let me know in the chat box if alpha and beta glucose is clear to you. Always you will see here also we can write this is alpha, positive it will be written here, and here also positive will be written because always it will be dextrorotatory only, right? Okay, yes, everybody. Guys, say something in the chat box, okay? I don't have superpowers. I'm a normal person with normal powers, right? I'm a teacher. I don't have superpowers to understand whether you are able to understand this or not without seeing your face and without seeing your chats also, right? So I need to know that whether you're able to understand that or not, right? Okay. So now we are going to see, if you want me to teach myself again, this is the 4th lecture where I am saying this thing, right? This is the 4th lecture, guys, where I am saying the same thing here. Yeah, if you want a teacher to be here and do those fun things, ha ha he he, I will not teach you anything, but I'll do ha ha he, and you'll be like, oh my god, such an amazing teacher, yeah, she's like amazing, yeah, she's amazing. Why she's amazing? Oh, she's amazing because she comes and she just makes like a fun of everything, and we enjoy the class, ma'am, right? Now if someone is here and making the structures and asking you, are you able to understand, that teacher is very strict, she's always teaching. She's a very strict teacher. Why? Because she is teaching. No, ma'am. She is not making fun. She is not doing fun. She is not singing, dancing, nothing she is doing. She is just teaching. That is why we will not answer. Now, if I crack a joke here, guys will be like, ha ha, ma'am, ha 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 ha. Right? So that's not what I want, guys. Right? So you are like just 1.5 months away. Be serious. And I want that seriousness in the chat box. Okay? Yes. Very good. Now, that is, I hope so you are able to also draw these structures, because if you want to see that what kind of, now if you guys are not serious, you want to see these kind of questions are asked. They will ask you the structures, right? Then you will see these kind of questions. Now, let me show you the question of JEE Advanced as well. This is JEE Advanced. This is the structure that this is the question that they will ask you. If you don't know how to draw the structure yourself, how you will be able to predict, right? That's why I am doing this much. Otherwise, so I could have just shown you. It's very easy for me to just show the structures. Okay, I'll show like this. I'll be like, okay, guys, so this is alpha and this is beta. You can see that yourself, right? So be happy about it that I am drawing it, because that will be asked to you in the exam. I have shown you the proof also, right? Okay. So now let us see alpha beta. We know that. Now let us see alpha beta. Alpha glucose melting point is 419, melting point is 423. Nobody asked that. Crystalline, but in JEE they can ask you, but still not important. Concentrated solution of glucose is 303. Preparation is 300 degree at room temperature. It is 98 boiling point of water, right? Now, let us see the cyclized structure. As because of cyclized, on the first carbon you see that on the right side that is called alpha, right? And on the left side that is called beta. Rest of the things are same, right? Okay, 36% you will see alpha and 64% you will see beta, right? Let us first draw the structures that we have seen. C1, it is on the right side, that is alpha, and on the left side that is your beta. Now, let us draw the Pyranose structures here, right? Okay, let us draw the Pyranose structures, right? Let us draw the Pyranose structures. Are you also drawing this along with me, or after the class you will try? Because if you don't try, no, it will become very tough for you. Now, I am going to draw the Pyranose structure. It is very, very simple. Only till here it was tough, but after this things are going to be very simple for you, right? Okay. Now, this is the alpha glucose that we have. This is the alpha glucose that we have, right? This is the alpha glucose that we have. Let us write it here. Alpha glucose, right? Now, can you see one thing? Just remember DR. I'm telling you DR. Just you need to remember Diksha ma'am is always right. Diksha R, right? So, DR. Now here, D means down, R means right. That means all the groups that are on the right side will be on the down side. All the groups that are on the right side will be on the downside. What do you mean by that, ma'am? Firstly, glucose is in the Pyranose ring. Pyranose ring is a 6-membered ring, right? So it is a 6-membered ring like this. It is a 6-membered ring. Let me draw it, right? It is a 6-membered ring. Let me draw it with solid this only, right? 6-membered ring, 1, 2, 3. Then you have 4th. Then you have 5th. Then you have the 6th, right? So that is the Pyranose ring. Now, it has on the left, upwards and downwards, it has the groups, right? Now, why I have this blank space over here? Anybody? Why I have this blank space over here? This blank space is for oxygen, right? Okay, the oxygen that we have drawn here. This is the oxygen that we have drawn. So this is 1, 2, 3, 4, 5, 6. So it depends how you want to draw it, right? I want to draw it on this side. So it will be 1, 2, 3, 4, 5 and 6. See one thing. I told you that on the right side, it will be on downwards, right? So here on the right side, we have on the first carbon, we have OH on the right side, right? On the second carbon, OH on the right side. On the third carbon, we have hydrogen on the right side. On the fourth carbon, we have OH on the right side, right? On the fifth carbon, we will see, right? Wait a minute, we will see, because here you have the cyclic chain. That is why we'll see what we will do, right? Let us mark the other things, or left side upwards, left side upwards, left side upwards, left side upwards, right? Okay, understood? Now, on the fifth carbon, how you will decide, ma'am? Ma'am, hydrogen is on the left side or CH2OH? Ma'am, it is not directly drawn here. How can we answer? So basically, always high molecular, like if you can't decide it by that downwards and right side, then you can say that the one which has more molecular mass will be upwards. So now CH2OH has more molecular mass, so it will be upwards. So it will be CH2OH, and this is your hydrogen, right? Okay, so that is going to be the cyclic structure of alpha D glucose. Glucose positive, and this is capital D, right? Okay, you will write this thing here. Alpha, this is capital D, and this is dextrorotatory glucose. This is the full structure here, right? If you want to write the beta, you can just draw it here like this. We know that if we talk about beta, there are two things that will change here. Anybody in the chat box, what are the two things that will change here? What are the two things? Here OH is on the left side. OH is on the left side here. And here OH is also on the left side. So it will be OH will be above, OH will be above, right, and H will be downward. So this is called beta. This is called beta. Right? Okay, understood? Okay, guys. Okay, everybody understood this or not? Is that clear to everybody or not? Right? Okay. OH on the left side. Right? Okay, guys. Simple. So now that was the cyclic structure, right? As you can see here, we know that glucose exists as a 6-membered ring, so hexagon. So it is having a Pyranose ring, right? This kind of ring, and this structure also we have drawn, right? Next one is epimers. So now what is a epimer? Epimer is that one in which in the open Fischer structure, epimer and anomers are very important. Again, our question has been asked in 2024 based on epimers and anomers statement, right? So epimers are those in which you can see that in one carbon, right, in one carbon, especially C1 carbon, you will have opposite configuration. So here you have the opposite configuration, right? So this is OH is on the right side, here OH is on the left side. That is why it is capital D. Acha, tell me one thing. Because on the first chiral carbon, they have opposite configuration. That is why it is called epimers. Why they are called capital D and capital D? They are called capital D, very important reason. They are called capital D because on the last chiral carbon, the OH is on the right side. Here the OH is on the right side, right? Here also the OH is on the right side. That is why they are called capital D, right? Now can you tell me one more thing here? Why it is called thereo? Why this is called erythio? Why this is called thereo? What is the term of thereo and erythio? Erythio, this is thereo. So erythio means when two same groups are on the same side. So this OH and OH are on the same side. So that is why it is called erythio. Erythio means on the same side. And thereo means on opposite side. Three things I told you from this structure, how questions can be asked. They can ask you capital D, capital L. Like if you have last chiral carbon, the OH group is on the right side, that is capital D. If an OH is on the left side, that is capital L. Right. Second thing I told you is about epimers. What are epimers? The first chiral carbon, if the configurations are opposite, that is called epimers. Now, what about erythio? Erythio means two OH groups or any group is on the same side, that is called erythio. If the same group is on the opposite side, that is called thereo. Right? Okay. Yes. Now we have next thing we have is anomers, right? Okay, now can you tell me what is anomers? They are called cyclic epimers, right? Cyclic epimers are called anomers. These are stereoisomers which differ at single chiral center, right? And they are in the ring chain tautomerism. Basically, they are cyclic epimers. You can say these are cyclic epimers. Now, the two sugars are different configuration only. Now, if you talk about alpha and beta, right, we know that in first chiral carbon, the configurations are opposite, right? The configurations are opposite, right? One is OH is on the right side. Here OH is on the downwards means it is on the right side. Here upwards means OH is on the left side. So that means two OH are on opposite side at the first chiral carbon. That means these are anomers of each other. Anomers are epimers, but epimers may not be anomers. Do you understand this statement? Anomers are cyclic epimers. See, if you talk about this side, is this a anomer? No, this is not an anomer, right? This is what you want to see. Now, this is not an anomer. Why this is not an anomer? Because it is open chain. So, open chain we call epimer only. See, anomer are further distribution of epimer. So, if I say, I am Diksha, right? I am Diksha Kaushal. So it's not like only I am Diksha Kaushal, right? Sorry, it's not like in my family, not in my family, I would say Kaushal is my surname, right? Diksha is my name, right? So in Kaushal, there are different, my parents are also Kaushal, my sister is also Kaushal, different Kaushals I have, right? So similarly, here, epimers, it can be open, but anomers, if you talk about anomers, these can be anomers, or we can also call it cyclic epimers. Why these are also called cyclic epimers? Because here, because here first chiral carbon have opposite configuration, right? Okay, yes. Now next thing is structure of fructose, right? So shall we see the structure of fructose? Firstly, let us see where it is found, usually in fruits, right? So it is ketohexose because it has ketonic group. It is obtained along glucose by hydrolysis of disaccharide sucrose. When sucrose will give you fructose and glucose, right? And fructose is levorotatory, right? Fructose is levorotatory, where it is written. It's not written here, but yes, fructose is levorotatory. Levo, it is minus, it is represented by small l. Right? It rotates a plane polarized light towards the left side, right? Now, it is natural monosaccharides found in fruits, honey, vegetable, right? It is pure form used in the sweetener, right? Okay. So, basically, it is like when we eat some fruits, why fruits are naturally so good in taste, right? They have natural sweetener, right? That is fructose, right? That is fructose in the fruits. So now as a OH group C side regular D sugar. Now they are saying that whether it is capital D or capital L, right? So generally fructose are capital D. If they have not mentioned, fructose exists as capital D, right? Why? Because on the last chiral carbon, the OH is on the right side. The OH is on the right side. Now, ma'am, is there any trick to remember fructose, ma'am? I always get confused here. Same trick is applied here. Same trick that we use for glucose, right? What is that same trick, guys? What is same trick, guys? Just remember, just write it down. Here you have a ketonic group, right? That is why a double bond will be present here. There will be one carbon. So this is primary, this is CH2OH, this is CH2OH. How many carbons you are left with? Can you tell me? 3. 1, 2, 3. 3 carbons we are left with. 1, 2, and 3. Number these things here. 1, 2, 3, 4, 5, 6. We know that because it is ketonic, so last will be CH2OH because we need to have 5. It is also pentahydroxy. Now we need to have one more OH. Right? So now this is the ketonic part. Now we are left with 3 OH. Same thing that we applied in glucose. Do you remember what I told you in glucose? Right? Okay. Do you know what I mean by when I told you what is glucose? Do you remember one trick that I gave you? If you remember that, that means you are studying very religiously. You are like giving full attention to the lecture. That means after this, you don't need any revision, right? If you are able to understand that thing, if you are able to tell me that thing. See, glucose, I told you one thing. I'm still waiting for your replies. I'm still waiting for your replies. Yes, everybody. Right? Now, I told you one thing. Yes, 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 everybody. I told you that third carbon will have OH on left side. Just remember this thing. Even in glucose, even in fructose. Right? So, simple tricks I'm giving you. Third carbon OH on left side. That same on glucose, same copy paste it on fructose. Right? So third carbon is on left. Third carbon OH is on the left side. This is OH is on the left side. Rest of them OH is on the right side. Right? So is this my structure of fructose? Everybody here. Everybody here. Everybody in the chat box. Yes, everyone. Yes, everyone. So that becomes my structure of fructose. Right? Okay. Understood? Just remember one thing. Again, I am writing it here. Third carbon, just have to remember that third carbon OH on left side. That's it. Same for glucose, same for fructose. Minimum tricks I am telling you so that you don't get confused, right? Okay. One student saying H on right side. That is also right. It's totally your choice how you want to write that. Only on third carbon H is on the right side, or you can remember only on the third carbon OH is on the left side, right? Okay. Now next is we made a cyclic structure for this one, right, for glucose. So can we make a cyclic structure for this one also, right? How to make a cyclic structure? Can you tell me how to make a cyclic structure? What I told you in glucose, I told you fifth oxygen, the fifth carbon oxygen, that will attack on the carbonyl carbon. So this oxygen is going to attack on the carbonyl carbon. The electrons are going to jump here. Now you will have a cyclic structure. So can we draw that cyclic structure here? Now this is the structure, right? Here see what you will have. You will have 2 CH2OH group as it is. This is CH2OH. This is CH2OH. Right? 2 is because nothing has happened to that CH2OH. No. So it will be as it is. I'll also refresh that for you. Right? So now this CH2OH is on that side. Now what else we have? What else we have? We have this fifth one. This is. Then we have this fourth carbon. Third carbon, then we have this second carbon. We know that if I say this is my first, this is second, third, fourth, fifth, sixth. From first to fifth, right? From first to fifth, yes, from first to fifth you have this. This is, I think, let us draw straight line here, right? So now this first to this fifth carbon, you have a ring formation, right? Okay. Okay. Okay, can you see this thing here? Now, here this oxygen I am writing here. This oxygen I am writing here. This hydrogen, now I will write simply fourth we have OH on the right side, and on third we have hydrogen here, right? And this is OH. Now we know one thing, that this O, double bond O, will become OH. But I'll tell you, this is a structure that you will get confused, right? So now now what will happen here? This is participating because this is the end carbon. So in reality it's not like this. It's basically, wait a minute, let me show you some structure here. Okay, just give me a second. So I don't know whether I have that much like, okay. So let's see this thing. I don't know if you're able to see this or not, right? You are thinking that this is the first and this is the last. In reality, it is actually making a cyclic structure like this. It is making a cyclic structure like this. So these two ends are meeting with each other. That is why the carbonyl is meeting with this one, right? Which is basically reacting here, right? Okay. Pen I can't fold, no. Pen I can't fold. Now, let us see this thing here. Now I'm going to change this structure, right? Why I'm going to change? Because this OH, whether it is on the right side or left side, that will tell me whether it is alpha fructose or it is beta fructose. So how I am going to change this? Right? How I am going to just redefine this thing. OH here, I am just simplifying this structure, okay? So that we have space for that OH, right? So here I am going to draw one new bond, right? Now this is going to tell me Whether my OH is on the right side or the left side, that is going to tell me whether I have alpha or beta, right? So alpha is always OH on the right side. So here OH is on the right side and CH2OH on the left side. And this is called alpha fructose. This is called alpha fructose, right? If I talk about, wait a minute, if I talk about that my OH is on the left side, right? If OH is on the left side and this is CH2OH, now this is called beta, right? This is called beta. So it is beta fructose. Beta fructose. Now how to mention the numbers of carbon? So this is the first, this is second, right? And here this is the first and this is second, right? This is first, this is second. Okay, now tell me, are you able to understand this or not? Right? Is that clear or not? Right. Okay. Yes. No, there is no instability factor basically here. It's just the configuration that it wants to see. Whenever a cyclic structure, like whenever you want to form a cyclic structure, because of the steric hindrance, they want to form a stable ring. We know that if it makes, see here maximum possibility for it is to form a pentagonal ring. And in glucose, the maximum possibility was to form hexagonal ring. So it preferred hexagon. You are saying that, ma'am, why this is not attacking, this oxygen is not attacking here, why this oxygen is not attacking? Because the new ring formation, why anything happens in chemistry? Because to gain stability. If ring is not stable because of angle strain, there are so many factors related to the ring stability. If ring is not stable, why will it form ring? Why will it not try to stay in open chain? It wants to form a ring. Why? Because it wants to get more stable, right? That is why this fifth carbon, not any other 3, 4 second OH are not attacking there. Okay? Understood? That is basically a ring formation thing, not the stability of these OH. Okay? Now, simple way to identify. Fructose consists of ketone. Yes, that's a very simple way to identify, right? So this is, just decrease the, Now, let us draw the structures, right? Again, let us draw the structures in a pyranose or furanose, which is a ring, in a furanose structure. Right, so let us draw the structure in a furanose structure, right? So this is, let us just delete this. Furanose ring, it is a 5-membered ring, right? From that ring we will have this structure, right? From that we will have this structure. So it will be what kind of structure, right? So 5-membered ring, let us make 5-membered ring here, right? 5-membered ring, 1, then you have 2, right? 2, then you have 3, 4 and 5, right? This is your 5-membered ring, right? This is your 5-membered ring, right? That you have. Now see, from this only we are going to make this. Oxygen here, I have drawn it. Either take 1, 2, 3, 4 from this side or this side. I am taking it from this side. So it is my first carbon. It is not first carbon. It will start from the second carbon basically, because the first carbon is not in that cyclic chain, right? First carbon is either outside or inside that. That means right or left side, right? So that will be second carbon here. This is third carbon, fourth carbon, fifth carbon. Now, if you talk about the groups that are attached here, right, groups that are attached here. So, on the second position, on the right side, let us draw on the right side, you have OH downwards. Again, remember, right means downwards. DR, remember DR. Again, DR students, D means down, R means right. R means right. Okay. So here OH is on the right side downwards, H downwards, here OH downwards again, And on the fifth carbon, what you have? Fifth carbon, tell me. There is no downwards, there is no right and left side here. So that is why CH2OH, more molecular mass, it will be upwards, right? It will be upwards. And H is downwards. So here on the first position, here you have CH2OH. Here you have third position, you have OH. You have H, and this is your complete structure of fructose, right? This is your complete structure of fructose. Okay? Yes, guys. So here is your complete structure of fructose, right? Okay. So now I'm going to copy paste this thing. Now that was your alpha fructose, right? So what about beta fructose? What about beta fructose? Beta fructose, what I need to change here? Anybody in the chat box? What I need to change here? Second carbon, here the OH is on which position? OH is on left side, right? And CH2OH is on right side. This is the first carbon, right? So CH2OH is on the right side. That means it will be downwards and OH will be upwards. So that becomes my first carbon. And this becomes my sixth carbon. Okay? Understood? Yes, everybody. This is how you're going to draw beta fructose. This is beta fructose. And these are, and beta fructose is levorotatory or dextrorotatory? Everybody, it is levo or dextro? Levo or dextro? Anybody in the chat box? Glucose is dextro. Fructose is levorotatory. So always you will see minus sign here. Here also you will see minus sign. This is alpha fructose, fructose, and this also will have minus sign. This is capital D or small d? This fructose is basically your capital D, right? So that is why it will be alpha capital D, right? Here also it will be beta capital D. Though here you can't mention that, so it will be written beta only, simple, right? So you can just simply write alpha here, right? Okay, understood? Yes, everybody? Ma'am, the position of up and down OH, yes, it can change the compound, right? So it depends on which position we are talking about. So if we talk about on the, here the second carbon, and in case of glucose, the first carbon, basically that carbon where the carbonyl group used to be there. Now here we know that on the second carbon, carbonyl group used to be there. So on the second carbon, if you have OH on the right side, that is alpha. If OH is on the left side, that is beta. Okay? And if you talk about glucose, in glucose, CHO group is on the first position, right? This, I think I have made it here, right? Now we know that CHO group was on which position? CHO group was on the first position. That is on the first position, if you see, on the first position, after the cyclic formation, if the first position is on the right side, that is alpha. If it is on the left side, it is beta. Okay, now students, tell me, is there any confusion regarding alpha and beta glucose? Alpha and beta glucose and fructose. So that is your, what they have drawn here, right? On the right side, this is your alpha, right? This is on the right side. On the left side, this is beta, right? Okay, understood? Now we know that fructose exists as a 5-membered ring, that is pentagonal ring, that is called Pyranose ring, right? We will represent bonds as vertical, this all we have done already, right? And these are the cyclic structure, this also we have done already. Exist in 2 cyclic forms, as I told you, right? One is alpha and one is beta. The ring thus formed is 5-membered ring and is named as Pyranose, that is called Pyranose. Furan is 5-membered cyclic compound with 1 oxygen and 4 carbons, right? So that is your alpha D and this is your beta D, negative, negative because of levorotatory, right? Okay, understood? Yes, students? Beta D means that on the last chiral carbon, it in the open chain, if you talk about the open chain of fructose, in the open chain, the last chiral carbon, the OH is on the right side, DR, right? DR. Right side means capital D it is. That's why I'm telling you, remember just DR. Somehow they will relate, okay? So, OH on the last chiral carbon, if it is on the right side, that is called capital D. If it is on the left side, that is called capital L. Okay, understood? Now, let us see disaccharides. So, disaccharides are we forgot to know, we forgot one very important structure, that is galactose. Galactose is ditto copy paste of glucose. Let's not draw it here only. Why to draw here? Why to do so much hard work? Huh? If you can just directly copy paste that thing. Otherwise, I'll draw. I'll start drawing only. Right? I'll be a drawing teacher now. Right? So, how to draw this galactose? Anybody? What is the difference between glucose and galactose? Anybody can tell me? Anybody who can tell me that? So, this is your glucose. Everything is same. There is just one difference. There is one difference here. The difference is on which carbon? Any idea? Any idea? Any idea? The difference is on the fourth carbon. Okay? The difference is on the fourth carbon. Here, OH was on the right side, but in this case, OH is on the left side. This is your galactose. Okay? This is your galactose. Right? Okay? Very simple. This is your galactose. Galactose. So, I will write down one thing here. The trick for you to remember that difference between in glucose C4OH on right. In galactose, this is the difference that I am telling you. C4OH on left. That's the only difference that they will have. Right? Okay. That's just exchange the OH and hydrogens in case of galactose on the fourth position. That's it. Okay, that's your galactose. Now, if you want to make the cyclic structure here, just copy paste the cyclic structure of glucose. Right, just copy paste that thing here. Just copy paste that thing here. Okay. Now, this is your cyclic structure. Right, on the fourth position means this position. Here OH, you have OH. Here OH is on the left side and H here. Here OH on the fourth position, that means this position. Again, OH is on the hydrogen downwards, means it will be on the right, means it will be downwards. OH will be upwards. Right, left means upwards. Right, now if you want to make, this is alpha galactose. Okay, this is alpha galactose. This is alpha galactose. Alpha galactose. Right? If you talk about beta galactose, guys, in beta glucose do the same thing. In beta glucose do the same thing. Right? Beta position was where OH was on the left side. Okay, left means upwards. So this is your beta galactose. Understood? This is your beta galactose. Right? Okay, any problem till here? We have done monosaccharides. Okay, we have done the major part of biomolecules. Okay, the major part of biomolecules we have done. Right? Now we will see disaccharides. For that you need to know the alpha beta glucose, alpha beta fructose, alpha beta galactose. If you know these things, sucrose is going to be just like 1 second work for you. Right? So let us see sucrose, sucrose, lactose and maltose. These are the 3 disaccharides in your syllabus. So if we talk about sucrose here, in sucrose, so I'll just make one chart here, and this is the only chart that you need to remember for your exam. right? After that, I'll just show you the structures, okay? So this is the chart. First write sucrose, then write maltose, then write maltose, then write lactose, right? These are the three disaccharides. Firstly, what they are made up of? Sucrose is made up of glucose and fructose. Maltose is made up of glucose and glucose. Lactose is made up of glucose and galactose. Okay, just remember this table. You will be sorted for this disaccharides also. How you remember? Glucose, 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 fructose, glucose, galactose. Okay, this to yaar, sucrose is the, like, everybody knows that because we have used it so many times that after hydrolysis of sucrose you get glucose and fructose. This to everybody knows, right? So after that, what you do, maltose is made up of same thing, that is glucose and glucose. And lactose, I told you one thing, that in milk you have lactose, right? And lactose is also made up of galactose, right? Okay, so in the milk we say that galactose is present, right? So here you have galactose. Now these are the three things that you have. Now what you need to remember, which is alpha, which is beta, right? So here alpha glucose and beta fructose, right? Here you have alpha glucose and alpha glucose, and here you have beta glucose and beta galactose, right? Alpha beta, alpha alpha, beta beta, alpha alpha, beta beta, alpha beta. Okay, that's how you remember this. Okay guys, that's how you remember this. Okay everybody, alpha beta, alpha alpha, alpha beta beta. Okay, I think by this it will be easy for you. Now let's remember the linkages, to which carbon which is connected. I'll tell you what linkage I am talking about. Just remember first this thing. C1, just remember one thing, it is 14. Wait a minute, that is 12, then you have 14, then you have 41. You just keep on increasing the numbers here. 12, 14, 41. Okay, 12, 14, 41. What is this 12, 14, 41, ma'am? I'll explain. What is this 12, 14, 41? This is the linkage that you have. Here you have C1, C2. This is C1, C4. This is C4 and this is C1. Okay? Okay, guys? Ma'am, is this the last chapter? Yes, after this we are going to start the revision. Right? Okay? Understood this thing? Okay, this particular chart is going to sort so many problems in your life. Right? Not your relationship problems, but these problems. Okay? Problems related to how much you hate bio. I can understand your pain, right? Because I have been like a non-medical student, so I know, like, not hate, but actually how much tough it is to remember these things, right? Okay, so I am telling you by some, how non-medical students are able to understand things. They understand by numbers only. So that's why numbers only I have given you. Alpha, 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 beta, 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 right? For 12, 14, 41. That's it. Okay, so now what we will do, we will see the linkages, right, in this form. Like, this is difficult to remember, but this is easy to remember, right? So now we know that how to draw the structures of individual things. Then simply we just need to do what we need to do. We just need to combine these two things, make a glycosidic linkage by extracting water out of that. Right, so what we will do here, see, first two things, this is glucose and this is fructose, right? Glucose, we know that this is the first carbon. On the first, second and third carbon only it is upwards, otherwise it is downwards only, and this is the last one. So this is your alpha glucose only. Alpha means on the first carbon you have OH, 1, 2, 3, and this is fourth one. Wait a minute, this is OH, 1, 2, 3, first carbon will define that thing, and this is second, third. This is your glucose, right? So that is your first one. This is second, this is third, this is fourth, this is fifth, and this is sixth, right? And what about fructose? Fructose, we know that from where it should start, this side or this side. So this is the first, this is second. This is first carbon, this is second, this is third, this is fourth, this is fifth, this is sixth. Now we need to see whether both are alpha, and see why it's not, I'm just checking this whether it's right or wrong, right? This is definitely alpha. Here beta, the first carbon should have OH, no? They have drawn it oppositely. Chalo, no issues. Let's erase this thing here. That's always I do this thing, right? Let's erase this because they should have drawn it like oppositely. Okay, I'm just going to change this here, right? I'm just going to change this thing here, right? Because if you want to draw the linkage between first and second, like that means first of glucose, first carbon of glucose, and second of fructose, right? So fructose, we know that how fructose is, how fructose looks like. On the fructose, if this is your second carbon, on the second carbon on beta, OH is on the left side. Left means it is upwards. So OH should be this one, right? OH should be this thing. So OH should be here. I'm just drawing the alpha, beta fructose here. OH you have here, H you have here, right? Then you have OH and H here. Not H, this should be CH2OH, right? This is CH2OH, CH2OH, right? This is first, this is second. On the third, you have OH on the left side. Again, left means upwards, right? On the fourth, you have OH on the right side, right? On the fifth, definitely you have CH2OH here and H here, right? Okay. Okay, so this is how you draw this thing, and this is how we will just draw the correct linkages here, right? One more thing here that we need to see. Chalo. By mistake, they have not drawn it right here. That's why I'm just correcting it, right? So now what will happen? OH and one oxygen from here. That means water will be taken out. One H from here and one OH from here. Water will be taken out. And you will have a linkage of oxygen here. So that will be this kind of linkage. That will be this kind of linkage you will have. Here you will have H and OH. This is H and OH. This is CH2OH. And this is H. Okay? Understood? And here you will have CH2OH. Okay, guys? So, C1 of alpha, we know that this is 1, 2, 3, 4, C1 of alpha and C2 of beta. This is 1 and this is 2. 3, 4, 5 and this is 6. Okay, so these two carbons will link with each other, right? This is the C1 and this is the C2. This is C1 and this is C2, right? Okay. Yes, definitely they are there in your last year questions, previous year questions. You need to know these structures, right? Okay, so C1 of alpha glucose, C1 of alpha glucose and C2 of beta glucose, right? Beta fructose. Okay, understood? Easy, guys, everybody, right? So that is your sucrose. And very, very important thing, this also is your previous year question only, that sucrose is a non-reducing sugar. That means it will not be reduced by Tollens reagent, Fehling solution, Benedict solution. It will not be reduced by these things, right? Next you have sucrose. right? Sucrose is dextrorotatory, but after hydrolysis give dextrorotatory glucose and levorotatory fructose. Now sucrose is also called as invert sugar, right? Why it is called invert sugar? Because if you talk about sucrose here, very, very important thing, it is going to give you glucose and fructose. Two things it is going to give you. Same thing. Sucrose, if you say, sucrose is actually dextrorotatory. Glucose is dextro and fructose is levo. But glucose and fructose, very important line I am saying now. Glucose and fructose are formed in equal amount. The concentration, the amount is same. That we are not saying. Students usually think that fructose is formed in more amount. I am not saying fructose is formed in more amount. I am saying that fructose has more rotation. The amount that it rotated towards right, that means glucose has less rotation towards right as compared to fructose has more rotation towards left, right? Glucose is less rotated towards right, but fructose is more rotated towards left. So the overall rotation from this is that it is going from plus to minus. That is why inversion of configuration is happening. That is why it is called invert sugar. Hydrolysis of sucrose brings about change in the sign of rotation from dextro to levo. The product is named as invert sugar. Okay? Yes, this can be asked in your assertion reasoning questions, right? So sucrose is dextrorotatory. This also we have done. Now, we have second one is lactose. Do you remember lactose? One is glucose, other is galactose, right? In lactose, one is glucose, other is galactose, right? Now, galactose, from here only you have lactose, na? Right? Galactose and this is glucose, right? Galactose also we know, glucose also we know. I told you it is 41. Fourth of this one, fourth of glucose and first of galactose, right? Fourth of glucose and first of galactose, right? So let us see that. If you see the position, both will be beta only. Beta glucose means fourth of this one. This is 1, 2, 3, fourth. On the fourth position, earlier what you had, see earlier you had here OH and here you had one OH. This was earlier what you had. This was not there. Right, earlier this bond was not there. It was like this. It was like this, okay? Earlier it was like this. So what exactly happened here? What exactly happened? Can you see this is beta D galactose, beta D glucose. This is the first, this is the fourth. They will lose water, 1H, 1 OH from there, and you will have the formation of this bond here. And this is called the formation of lactose. Right, and here what you need to remember, C1 of galactose and C4 of glucose, right? Okay, yes, everybody, that is, it is more commonly known as milk sugar because it is found in milk. It is composed of beta D galactose, beta D sucrose. Always, usually it is asked, free aldehydic group may be produced at C1 glucose unit, hence it is a reducing sugar. So basically they are saying that if you see this thing at the C1 unit, this particular unit, you can have free aldehydic group that can be formed. That is why this is a reducing sugar. So mainly just remember one thing, all disaccharides are reducing only, right? All disaccharides are reducing except for sucrose. You don't have to remember each and everything. Just remember all disaccharides are reducing. But exception is sucrose. That is why sucrose is asked, right? So sucrose is not your reducing sugar, right? Okay. So it is a reducing sugar. Lactose is a reducing sugar, right? Then you have maltose. Do you remember what I told you in maltose? 2 glucose units you will have. Both will be alpha glucose, alpha glucose. Linkage will be of 1 and 4, right? Linkage is of 1 and 4. So can you see here whether the linkage is of 1 and 4. So if you can see here, this is the first alpha only, 1, 2, 3, 4, and this is 5, this is 6. This is again, this is 1, 2, 3, 4. Oh, 1, 2, 3, 4, 5, and this is 6. I told you between 1 and 4. right, between 1 and 4, right? So this is 1 and this is 4, right? What they will do, they will lose water, OH from here, H from here, and they will have this kind of linkage, and hence you will have the formation of this disaccharide, right? This disaccharide will be formed here, that is maltose. What you need to remember, C1 of 1 alpha and C4 of another alpha glucose units, they will combine, and this is definitely a reducing sugar, right? So a free aldehyde group can be produced at C1 of second glucose in the solution. It shows reducing property. That means they are saying at this position CHO group can be found. They can also ask you why they are showing reducing character, because the glucose C1 will have the aldehydic position, right? Okay. Yes, I'll give you break, don't worry. Just let me complete the polysaccharides also, because the link will break. Otherwise, because after that we are going to jump to proteins, DNA, RNA, that has no relation with this thing, right? There is no relation of DNA, RNA with proteins, and they are all separate topics, right? Okay. Okay. Now you have, if you talk about starch, these questions are also asked, right? Now, if you talk about polysaccharides that are formed of n number of monosaccharides, we have 2-3 very important things. First is starch. Starch is made up of amylose and amylopectin. The linkages here they will ask you. In amylopectin, what are the linkages? In amylose, what is the linkage? So, if you talk about the amylose, right, in amylose, the linkage is of alpha D glucose, and there is only C1 and C4 linkages here, right? So it is C1, C4 linkages of alpha D glucose, right? Now things will be same as maltose only. You will use alpha glucose only, right? So linkage of C1 and C4 linkage of alpha glucose, alpha D glucose units held together by C1, C4 glycosidic linkage, that is called, this thing is called glycosidic linkage. Okay, then that is called, if n number of alpha D glucose are linked here, that is called as amylose. Now what is amylopectin? Again you have same alpha D glucose only, but the difference is the branching. That means C1 and C4 linkage of alpha D glucose will be there, but here you will also have these alpha D glucose will also have C1 and C6 linkages. So here you have first and this is your sixth, right? These two will also form the linkages. So in amylopectin, you have C1, C4 linkages plus C1, C6 linkages. That is why in amylopectin, you will see this kind of branching, right? That is why you will see this kind of branching here, right? Okay. Okay, guys. Now, alpha D glucose units in which chain is formed by C1, C4 linkages, glycosidic linkages, whereas branching occurs by C1, C6 glycosidic linkages. Okay, understood? Yes. Now, if you talk about glycogen, it is similar to amylopectin. It's just that remember, starch has two things, amylose, amylopectin. In amylose, you have C1, C4. In amylopectin, you have C1, C4 plus C1, C6. But in glycogen, you have same thing as amylopectin. It's just that it has more branching here. More C1, C6 linkages are present here. Otherwise, linkages are same only. Carbohydrates are stored in animal body as glycogens. In our body also, carbohydrates are stored as glycogen. Whenever we need energy, for example, we are on fast, we are not eating something, glucose is not in our body. So what our body will take up that glycogen, it will use that, right, convert it into glucose, right, known as animal starch because its structure is similar to amylopectin, is rather more highly branched, right? Okay, so it is more highly branched, so that is your glycogen. It also has same thing, that is C1, present in liver, muscles, brain. When the body needs glucose, enzymes break down glycogen to glucose, right? So whenever we are not in a situation to eat something, how you are surviving, right? When you just don't die if you don't eat for 3-4 hours or don't eat for one day, right? How fast happens? Because glycogens, our body will break this glycogen to glucose. That is why it is advised that you should always you should have fast, like maybe 2 months, maybe after 2 months you should have at least one fast. Reason is not that okay because of any religious thing. Why in all the religions we have fast, right? Why in all the religions there is some fast? It's not because God wants to, give punishment to your body. No, it's just a scientific factor behind that, okay, that it was designed so that you can do fast and your body can heal from that, right? The unnecessary cells in our body which are not required, we can, damage those cells, right? Okay. Now, next is your cellulose. Now, if you talk about cellulose, it occurs exclusively in plants and most abundant substance in plant kingdom. It is predominantly constituents of cell wall. Cellulose is straight chain. Now, basically, if you remember that we used to do cells and tissues, do you remember that cell and tissues chapter 9th and 10th class? 9th class, yeah, right? So there was cell wall. In animal tissue, in animal cell, there was no cell wall. There was no cellulose. But in plant cell, there was a cell wall, right? So this is what they are talking about, that in the cell wall, you have cellulose, right? So that is in the plants, right? So what about cellulose? What kind of glycosidic linkages it has? It has beta D glucose. Starch, two things. Amylose, amylobactam, both have alpha D. Glycogen, alpha D. But here you have beta D, right? Which joined by glycosidic linkage between C1 of one glucose and C4 of other glucose unit. That means you can just simply write it here. Beta D glucose, and that is C1 and C4 linkage. Okay, C1 and C4 linkages here, right? Okay, yes, all these belongs to polysaccharides because n number of linkages are there, right? So in polysaccharides, starch, amylose, amylopectin, then you have glycogen and cellulose. These four you should, they're not going to ask you the structure. Just remember the linkages here, right? Okay. Okay, guys. Now, next is amino acids that we will do after break. Half of the chapter we have done. Right now, after this, we are just left with some theory part. Okay, we are left with not even half, more than half of the chapter we have done. So that was a big chunk of biomolecules. That was about the main time that we took was to draw the structures, right? Alpha, beta, glucose, alpha, beta, fructose, alpha, beta, galactose, right? After that, now we will have only theory parts, right? Okay. So now I'm going to give you break, right? I'm going to give you break, right? And the break is I'm going to give you break for how many times? Like maybe for wait a minute. Oops. So it's 7:13. So I'll see you at 7:25. Okay, 7:25 p.m. I'll see you. Okay, the class is going to resume at 7:25 p.m. and we are going to also solve the previous year questions. So be here, have that patience so that we can also complete the rest of the part, RNA, DNA. Just like I told you tricks for glucose, fructose, maltose, all of these things. I'll also give you tricks for rest of the chapter, right? Okay, so yes. Okay then guys, I'll just start the timer. I'll see you at 7:25 p.m. And those who are asking the questions, guys, that are there, okay? You need a proof for that. There are so many questions that I have taken up for you, right? Okay, so these are your previous year questions only. That's why I'm saying that stay here, right? Have that patience, because after that we are just left with theory part, and after theory we are going to do the previous year questions only. Right? Okay. I'm so sorry. Okay. I am so sorry. I'm so sorry. I'm so sorry. Okay. I'm so sorry, guys. Now, am I audible? I'm so sorry about it. So this tells that how much I am like when I'm consumed in teaching, no, I'm totally in that zone. I'm totally in that word. I don't care what is happening around me, right? So yes, now or not audible from a long time, no. So I'll just again teach that. I didn't knew that from the break time only. I forgot to unmute myself, right? Okay. So now I think that was the first page, right? Okay. Okay, guys? Yes. Now, some fun also in the class. Okay, so carbohydrates we have completed. Now we are going to do proteins, right? So proteins, right, which are very, very important, necessary for your body. This protein is basically made up of amino acid, right? The monomer of protein. That is why it is so important to, write something on the chat box. Now, protein are made up of amino acids. Now, what are these amino acids? Just like disaccharides were made up of monosaccharides. So these proteins are made up of these amino acids, the linkage of these amino acids. What are these amino acids? Amino acids are basically which have COOH group also and NH2 group also. It has these two groups here. So this carboxyl group is acidic in nature and this NH2 group is basic in nature. And in your syllabus, you will see alpha amino acids only. But there are other amino acids as well. If you see this thing here, right? If you see this thing here, you have COOH group. This is the next carbon, this is next carbon, this is next carbon. So here, let us see the carbon that is next to the carbonyl carbon of carboxylic acid, that is called alpha. This is beta and this is gamma, right? So now, if you say that NH2 group is attached to this alpha position, that is called alpha. If it is attached to this beta position, that is called beta amino acid. If it is attached to this gamma position, it is called gamma amino acids. Right? So in your syllabus, you will have alpha amino acids only that will look like this, where on the alpha carbon, you will have NH2 group attachment. Right? Now, next thing is, it will have the formation of Zwitterion. So what are these Zwitterions? This is your base and this is acid. Now what is the quality of a base? What is the quality of a base? A base is the one which can accept H positive. An acid is the one which can donate H positive. Right? So this H positive will be donated to this side. Right? And hence what you will have here, the formation of this Zwitterion. Right, this is the Zwitterion that will be formed here, right? And here you will have NH3 positive and this is COO negative, right? Now, depending on this Zwitterion is actually amphoteric in nature, right? That means it will react both with acid and bases, right? Now, next thing is, what are the different amino acids that you are going to have, right? Okay, so different amino acids, guys. I think because of some he was about to announce something very, very important to you guys, right? But I think because of some electricity thing, right? I think the power cut, he was not able to continue with that. That's why he texted you on with a video message he sent on Telegram channel, right? That he will continue that thing once that issue is over, right? Okay. Yes. Now, amino acids. Now, if you talk about amino acids, now depending upon this R group here, right? This R group can be, this alkyl group can be different alkyl groups you can have. Depending upon that, you will have different amino acids, right? And all of them are very, very, very important for you, right? Glycine, if you have H here, right? That is called glycine. Alanine, that means CH3. Valine, that means CH3 twice and this is CH. Leucine, that means CH3 twice, CH2. Isoleucine means you will have an iso group here. Instead of this CH3, you will have CH3 over here. Then you have arginine, right? That means you will have NH double bond C, NH3, NH, CH2 triple, CH2 thrice. Then you have lysine. Then you have glutamic acid, aspartic acid, glutamine. then asparagine, then you have threonine. Now I'll tell you what are important for you. Like you will say, ma'am, so many amino acids we have. Do I have to remember all of them or not? So I'll tell you what are the things that you need to remember. Firstly, glycine, alanine and valine is very, very easy, right? Then you have leucine also, adenine and lysine. These are all are very easy, right? From here, you have these two acids, right? This so you can easily remember CH2, CH2, COH, CH2, COH, right? Then from here, you can remember serine, cysteine, right? These two are important. Then here you have histidine, right? This is important. Then I think that's it. Even if you don't want to remember histidine, that is also okay. But for JEE Advanced, so you have to remember all of these, right? For JEE Advanced, though, you have to remember all of these. You can't skip anything here, right? Even for JEE Mains also, you should remember everything. But I'm just telling you the main important amino acids from this one, right? That are frequently repeated. But you need to remember the full chart here, right? Okay. Now, another question that is asked from here is acidic and basic amino acids. If your NH2 group is more, right, the definition is given here only, I guess. Now, if amino acids group is less and acidic group is, carboxylic group is more, that is called acidic amino acid. If amino acid, that means if amino group is more, that means basic group is more, that means it will be a base. If they are equal, that will be a neutral amino acid. Let's take an example. So for example, let us talk about lysine. Lysine, this is R, this is CHC double bond O or COOH and this is NH2. It will be the full structure. Now here you have two amino groups and one COOH group. So here you can say this will be a basic amino acid. This will be a basic amino acid, right? All of these are going to be neutral amino acids, right? All these are going to be neutral amino acids. Why? Because there is no more NH2 group here present. Amino group is not more here. Here you have more COH group. That is why it is going to be acidic amino acid. Here you have NH2, NH2. These two are going to be basic amino acids, right? Then this one this will be the neutral amino acids, right? Okay, neutral amino acids. Okay, understood? Yes, everybody? Now, next is essential and non-essential amino acids. Essential are which cannot be synthesized by our body and our body needs it externally, right? That is why there are so many deficiencies in the body, right? So now, if you have something that your body can generate itself, that is called non-essential. That means even if you don't eat that thing, don't give your body that thing, your body can survive. Yeah? Your body will not have deficiency of that thing, right? So that is called non-essential. Now let us talk about proteins. Now proteins are made up of amino acids only, right? So how they are made up of? Proteins are polymers of alpha amino acids, right? Then and they are connected to each other by peptide linkages. What? See, in carbohydrates you have glycosidic linkages and here you have peptide linkages. So exactly what will happen? So for example, you have this thing, right? So this is your one amino acid, this is another amino acid. So this amino acid is going to always, when there is linkage, water will be eliminated from that. So here you will have elimination of OH, not H from here and two, wait a minute, yes, OH from here and one hydrogen from here. Then you will have the linkage as C double bond O. This is NH. This thing is called your peptide linkage. This thing is called your peptide linkage when amino acids will attach with each other with elimination of water, right? This is called peptide linkage. And this is why this is called glyella, because here glycine and alanine is used, right? So hydrolysis of peptide, when you hydrolyze this thing, that means when you add water, it will be opposite, reverse of this thing. That means you will add water, here OH will be attached, here hydrogen will be attached, and you will get the amino acids from where it was formed initially, right? Then you have, here they are saying that peptide linkages in amide formed between COH and NH2 group. Now, basically 2 amino acids, they are dipeptide, 3 amino acid tripeptide, 4 amino acid tetra, many amino acids, that is called polypeptide. And in proteins, you have polypeptide chains, right? There are so many peptide chains available, right? So if you talk about protein, basically protein is of, this is a tertiary structure of protein. So I'll come to this point. But firstly, I'll teach you the primary, secondary, tertiary, and quaternary structure. There are 4 structures of protein, right? So, how can we imagine these 4 structures? See, when amino acids are linked to each other with the peptide bond, this is one amino acid, this is other amino acid. After elimination of water, they are attached to each other. This will form one peptide bond. In that way, if so many amino acids are linked to each other, that is called primary structure. When we are just zooming out. You know that video where they have shown the eyes of one person, and from that they zoomed out, they showed the human, then after that they zoom out more, they showed the country, then the world, then the universe, then this galaxies, right? In the same way, we are going to zoom out here, right? So how we are going to zoom out here? So if you talk about the primary structure, firstly, we will talk about individual amino acids, how they are forming the peptide bond with each other, right? So these are the amino acids, and they are forming the peptide bond with each other, and that is how you got the peptide bonds, and this is how you got the structure of this protein. That is the primary structure of protein, right? So that is the first structure. If you talk about the secondary structure, here I am saying zooming out. Here I am not saying the peptide bond. I am saying you have 2 chains of amino acids, how they are linked to each other, right? So basically there is hydrogen bonding between them, right? So there are 2 types which can exist. One is alpha helix, other is beta plated. Alpha helix is like this, it's like a spring, and beta plated is like this. So these are the 2 structures that can exist. I'm drawing here alpha helix, and this is beta plated, right? This is beta plated structure, right? So if you talk about these 2 structures, for example, there is one long chain. Okay, let's talk about a snake, right? For example, you have a snake. How the atoms of that snake, atoms, that means how the cell, the molecules of that snake, how the body parts of that snake are connected to each other is the peptide bond, right? That is the primary structure. Now we want to see snake is like in which position. It is like rolling like this, it is moving like this. What kind of structure it is obtaining from that peptide bonds? So the way it is arranged, because of the attractions, the hydrogen bonds between the peptide bonds, that is called the secondary structure. This arises due to backbone of polypeptide chain and the hydrogen bonds, right? That means here you have some peptide. Here also you have peptide bond. Here you will have hydrogen bonding. Here you have peptide. Here you have peptide. Here you have hydrogen bonding. Right? Here you have peptide. Here you have peptide. Here you have hydrogen bonding. So this is how the structure will be formed. That is called the secondary structure. Beta pleated structure. The peptide chains are stretched out to maximum extension and then joined by intramolecular hydrogen bonding. Right? Okay. Then we have tertiary structure. Now you have seen that snake was going like this and this. Now the snake is in a pipe. Okay. Now just imagine the snake is in a pipe. So you have a pipe in which the snake is moving. This is your snake. This is your snake. This is the snake. It is moving in this whole pipe. So basically this is the tertiary structure. This is basically when we talk about that how different peptide chains are linked to each other. That was the structure of one, and there we were talking about how different peptide chains are moving in a one direction, right? In that way, right? So it represents overall folding of peptide chains, further folding in a secondary structure, right? So this is your snake, that is throughout it is moving, right? This was the primary. This was the secondary. Now, how throughout this secondary chain is connected? For example, this is a rubber band, okay? This is a rubber band. If I stretches it out, this is my primary structure, okay? This is my primary structure. Now, I am saying that this is how it looks like, okay? This is my secondary structure. This is how, because of this stretching, because of this strength between it, because of the bonds, right? It is connected like this. Now, I am rotating it like this, okay? I am rotating it like this. This is my tertiary structure, right? This is my tertiary structure. So, in the same way, right, this is your tertiary structure, right? This whole is your tertiary structure, how this is moving throughout this particular fold, right? So, that is your tertiary structure. Now, tertiary structure are of two types, globular and fibrous, that I'll show you, right? It arises giving two major structures, that is fibrous and globular. Now, you have fibrous and globular here. Fibrous means which are insoluble in water, right? If you see our hairs, right, they are not soluble in water. We put our hair in water, it will not get dissolved, right? Otherwise, we all will be bald, right? But we are not, right? The reason being they are not soluble in water. Then we have globular, which are soluble in the water, right? They are definitely soluble in the water, right? Okay, so now polypeptide chains run parallel and held together by hydrogen and a disulfide bond, then the fiber-like structure is formed. For example, our nails, our hairs, they have fibrous protein, right? Like keratin. If you have ever heard of keratin treatment on hairs, they'll say that will provide you external keratin to your hair so that it can get that protein. That protein in our hair is keratin, I think cysteine also, cysteine or something like that was also one more protein in our hair. There are so many proteins basically. Globular is in our like other parts of the body that get dissolved, right? So chains of polypeptide coil around to give spherical shape. That is called globular. That is insulin, albumins. These are globular proteins, right? Okay, understood. Now next is the quaternary structure. Quaternary structure means when I have this rubber band, I have one more rubber band, I have one more rubber band. How 3-4 rubber bands are combined to each other, right? That is my quaternary structure, right? So, proteins are composed of 2 or more polypeptide chains referred to as subunits, right? The spatial arrangement of these subunits with respect to each other are known as quaternary structure. This is one chain, this is other chain, this is third chain, this is fourth chain. How they are connected to each other, that will be my quaternary structure, right? Okay. So this they have shown, right? So basically this is your primary, this is amino acids are connected to each other. Secondary is what kind of shape they are forming, beta or alpha, right? Then you have tertiary. For example, snake is in the pipe, so how it is like forming a throughout structure, right? A throughout structure. Then so many peptide chains are combined to each other, that is called quaternary structures. Okay, these are the 4 structures. Next is nucleic acids. Next is nucleic acid. So let us see nucleic acid. I think guys, JEE people are not at all interested in biomolecules, is it? Do you hate biomolecules so much? So, like, the students are not present here. So, what should I was so about to take the previous year questions also. So, should I take the previous year questions or we'll do that some other day? Because previous year question, what's the point of doing previous year question with such less students that are present here? Huh? What's the point then? Okay. Now, nucleic acids. So, I'll just ask the students after completing the lecture, if join, then we will continue. Otherwise, we will do the previous year questions some other day, right? Because 3-4 we can do, but see the live watching, right? It is disappointing for me also, right? So much hard work I do for you, but then in return, this is what I see, right? So, I feel that I'll see that in the end how many students are present here. According to that, we will see, right? So now, nucleic acid. So nucleic acid is basically, I don't feel like, ma'am, do it. Monisha, I can do it, but do you think that is possible with such less live watching? Huh? Let me ask the students. I have just asked the students, let me see how many students join after this. Now, waiting from 2 hours. How sweet. Okay, so now nucleic acids. Now guys, chalo I'll do. Okay, nucleic acids, basically there are two type of nucleic acid, nucleotides and nucleosides. In nucleotides, you have all the three things. You have sugar, you have phosphate group, you have the nitrogenous base as well, right? But in nucleosides, phosphate base is missing, right? So that is the difference between nucleotide and side. Side means, what is a side? Side means when you sideline someone. So here what we have just ignored. When you ignore someone, that is giving them a side. So we have ignored phosphate group here. Otherwise, nucleotides are made up of three things. One is pentose sugar, phosphoric acid. Then there is nitrogen containing base, right? Phosphate sugar is either ribose or D-ribose. So when we talk about DNA and RNA, in DNA you have ribose, in DNA you have deoxyribose sugar, and in RNA you have ribose sugar, right? Phosphoric group may be different phosphoric group, but nitrogen containing bases can be A, T, G, C, U. These are the 5 nitrogen bases that you will have, right? So let us talk about these nitrogen bases and all the things one by one. First is the sugar. First part is the sugar. In the sugar, you have beta D ribose and you have beta D2 deoxyribose, right? That means on the second position, this is the second position, right? So on the second position, this OH will not have the oxygen. So on the second position, in both the cases, you have hydrogen. Here you have one hydrogen and you have one OH. That is the difference between ribose and deoxyribose. This is there in RNA. This is there in DNA. So first part we have seen. The second part of this thing is the difference. Okay, the difference I told you that in nucleoside you will have the base and sugar, but in nucleotide you will have base, sugar and phosphate. All the three things will be there. Right? When you don't discuss phosphate, that is called a nucleoside. When you ignore the phosphate, that is called nucleoside, right? So now, if you talk about sugar that we have already talked about, the second part is the phosphate group. So phosphate group can be phosphoric acid, phosphomonoester, phosphodiester, phosphotriester, anything. So what is phosphoric acid? P double bond O, OH, OH, OH. Replace this H by R, that will be phosphomonoester. Replace 2 hydrogens by R, that will be diester. Replace 3 hydrogens by R, that will be triester. So basically phosphoric acid or its derivatives can be used here, right? Okay. Next we have the third thing is nitrogenous bases. In nitrogenous bases, basically I told you A, T, G, C, U. These 5 bases you have, right? So what is the basic criteria? What is the base? Base means what is the structure, right? So they are formed from 2 things. Either they can be derivative of purine or they can be derivative of pyrimidine, right? Now, let us see, this is pyrimidine and this is your purine. Let us see how they are derivative of purine and what are the derivative of pyrimidine. So, these are the 5 bases that I was talking about. This is purine. Here, this is also purine, right? This is pyrimidine. This is pyrimidine, right? This is also pyrimidine. This also can be asked, right? Pyrimidine, right? This is also pyrimidine, right? So all of these things, right? What are your purine? A and G are your purine bases. C, T and U are your pyrimidine bases. Now, if you talk about the linkages here, right? In DNA, what you have and in RNA, what you have. That is a major difference here. In DNA, you have adenine, you have guanine, you have cytosine, you have cytidine, you have thymine. In RNA, you have adenine, guanine, cytidine, you have uracil. So basically, you can say one thing here. Right? It should be cytosine. Okay? It should be cytosine here. Just remember one thing. In DNA, you will have A and T. Here you have GC. It's at GC. At GC. At which thing? At GC. At government college. At GC. Right? And this is your, just replace T with U. AU. This is AU. This is GC. Now, very important thing. Here you will have double bonds. Not direct double bonds, but means the hydrogen bonds. Right? Here you will have 2 hydrogen bonds. You can just directly draw by a single line. 2 hydrogen bonds. Here you will have 3 hydrogen bonds. Here you will have 2 hydrogen bonds. Here you will have 3 hydrogen bonds. So these kind of question can be asked to you. In RNA, what you have, in DNA, what you have. A is always linked to T and G is always linked to C. A can be linked to U in case of RNA and G is always linked to C only. Right? Okay. Now, next is the structure of DNA. Right? As you know that now they are saying how the structure was developed. It is actually a double standard helix structure. Right? So how it was developed? 2 nucleic acid chains are wound about each other. It's like a spiral. Okay. When you connect it like this, it's like a spiral. This is how it is connected. Right? It's the first helix and this is your double helix. This is the other helix. So that is your double helix structure. How 2 helix structures are connected to each other by hydrogen bonds, right? So 2 nucleic acid wound about each other held together by hydrogen bonds between the pairs. 2 strands are complementary to each other. Firstly, let us see what we are saying here. So basically, this is your first structure, okay? This is your first structure, right? It is going like this, like this, like this, like this. And this is your second structure. This is your second helix. It is going like this, 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 and so on. This is your alpha double strand structure of DNA. And here, as you can see here, this is T, this is A, this is G, this is C. In G, you have 3 bonds. In AT, you have 2 bonds. In CG, you have 3 bonds. AT, again, you have 2 bonds. Again, this is 2 bonds. That means one is A, other is T. Here you have 3 bonds. It is one is G, other is C. Because of these hydrogen bonds between the bases, they are connected to each other and they are making double standard alpha helix structure. Right? Okay. Now, let us see this thing here, that 2 strands are complementary to each other because the hydrogen bonds are formed between specific pairs of bases. And these specific pair are AT and GC. Adenine forms hydrogen bond with thymine, whereas cytosine forms hydrogen bond with guanine. Right? Now, DNA is known to be double helical structure. 2 helical are held together by alpha bonds. Sugar and phosphorus groups appear to rails and the bases appear in the rungs. Now, what do you mean by this? Right? So now, phosphate and sugar group in the rails means when you are like on some stairs, no, the stairs are the rails, and the side which you hold, right, the side line of that thing, side in which you have the support, that is called the rungs. Okay, so the side, they are saying the sides have the nitrogenous bases, and in between this you will have the, this is the nitrogenous base, this is the nitrogenous base, this is your sugar, this is your sugar, this is your phosphate group, this is sugar, this is phosphate, this is sugar, this is phosphate. That means they are in the rails, and these bases are in the these are in the rails, and these bases are in the rungs. Yes, okay, and these bases are in the rungs. Okay, so that's a new thing, right? Can ma'am, can JEE students listen? Saranya, this is for JEE students only, right? Okay. In secondary structure of RNA, single strand helix is present. Sometimes fold it back, right? So what you mean by RNA? In RNA, again, what will happen? You will have three kind of structures. One is primary, secondary, and tertiary. So secondary structure is your alpha helix and beta helix structure. Tertiary is single strand may be rewind over itself. That is called the tertiary structure. When it is rotating on itself only, that is called the tertiary structure. Now, RNA is of three types. First is messenger, ribosomal, and transfer RNA. Right? So, these are the three types of RNAs that you have. Next is complementary bases. So, as I told you, adenine will form a pair with thymine in DNA, and guanine will form a bond with cytosine with 3 bonds. It is with 2 bonds, right? But when you talk about the RNA, in that case, you will have, instead of thymine, you will have uracil, right? So when you talk about this, is basically they are talking about the pair of thymine or uracil with adenine, right? So they will have 2 hydrogen bonds, and this is going to have 3 hydrogen bonds. Okay, now they are going to have 3 hydrogen bonds between them, right? So always remember A double bond, that means 2 hydrogen bonds with the T, or A forms 2 hydrogen bonds with U. This is in case of DNA, this is in case of RNA, but guanine will always form 3 hydrogen bonds with cytosine. This is whether it's DNA or RNA, right? Okay. So that was a structure of DNA and RNA. This already I have shown you. DNA is a double helix structure, right? Double helix structure it is, but RNA is single, right? It's a single helix structure, right? Okay. Now next is vitamins, right? Let us talk about vitamins now. So vitamins are, like we all know, very, very important for our body, right? What you think, what are the vitamins that are important for your body, right? So vitamin D, vitamin K, vitamin B12, right? All these we will talk about, right? Okay, now let us see what kind of question can be asked from here, right? So that we can also do the previous year question after completing this. Just 10 minutes of theory is left. After that, we will do previous year questions only. So vitamins are organic compounds required in small amounts in our diet, right? That are very essential for our body. And if you don't have those vitamins, you will have some deficiency in your body, right? So basically, we have vitamin A, B, C, D, E, K, right? All these vitamins we have, right? Now, there are 2 kind of vitamins. From this table, the questions are asked. There are 2 kind of vitamins. One is fat soluble, other is water soluble, right? What is fat soluble? EDEK. Just remember EDEK. You can remember. I remember by EDAK. You can remember ADK. AD. Do you remember AD? AD. ADEK. ADEK. Okay. Add A for, you can remember add EK. ADK. Okay. ADEK. Or you can also remember by KEDA. 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 Just remember KEDA. K, E, D, A, these are fat soluble vitamins. Right now, it's a very important thing that it is like stored in our body. Right, so vitamins which are soluble in fat and oils but insoluble in water are kept in this group. They are stored in our body. That is why what will happen, they are stored in liver and adipose tissues. But if you talk about water soluble vitamins, now water soluble vitamins, what happens, that water soluble vitamins will be excreted out by urine, right, because they are soluble in water, so they will be excreted out by urine also. Vitamins which can soluble in water and insoluble in fat oils are kept in this group. They are readily excreted in the urine and cannot be stored in our body. Now the exception is important here, that all the vitamin B and C can be stored in our body, cannot be stored in our body, except for this thing, except for vitamin B12, right, except for vitamin B12. So whenever, if you ever gone for any vitamin test, this is important for those students also who are not interested, because now the interested part has started, right, that vitamin B12, like whenever you go for any vitamin test, they will check vitamin B12, they'll check vitamin D, that are two most important things. Vitamin E also, usually it is not deficient, but vitamin B12 and vitamin D are mostly deficient in most of the people, right, especially B12 will, the people who are vegetarian, the people who are like, who don't have non-vegetarian diet, mostly they have the deficiency of vitamin B12. And now we know that nobody wants to go out in sun and everybody is sitting at home, like in their rooms. That is why vitamin D deficiency is also there in people, right? Okay, so now question they can ask you, out of the following which is fat soluble, out of the following which is water soluble. Kida is fat soluble, but rest, that is B and C, are water soluble except for vitamin B12, except for vitamin B12, right? Now let us talk about some vitamins here, right, and their deficiency. If you talk about vitamin A, right, vitamin A, it is found in fish oil, and it is also found in carrots, butter, milk, right? It is like very important for your eye health, right? It is very important for your eye health. So if you don't have the this is hardening of cornea of the eye, diseases that will affect our eyes can occur because of the deficiency of vitamin A. Then vitamin B2. Vitamin B2 is also called a riboflavin. It is there in milk, egg white, liver and kidney itself. Here also it will hardly be deficient, right? So digestive disorders, burning sensation of the skin, all of these things can happen. Then vitamin B6, it is present in milk, egg yolk, cereals and grams. That is why it is so important to have Lenten cereals, grams, right? And next is vitamin B12. Now this is important for you, like for your family also, you can listen to this thing, that here it is actually found in meat, fish, egg and curd, right? So there are very less sources of vitamin B12. So how many of you are actually vegetarian? How many of you? How many of you are vegetarian, who don't have anything, like forget about any non-vegetarian, proper non-vegetarian, you don't even have milk and curd, right? Then though you're properly like gone, right? Because vitamin B12 will present. Then why I am stressing on this thing, because I have this deficiency, I am a vegetarian, and hence your voice is low. Is my voice low? Wait a minute, let me check. Let me check, is my voice low? Is my voice low? Let me see. Hello, hello. Now is this better? Now is this better? Yes? I can't live without non-vegetarian. Then that is good for you, because these things are there in non-vegetarian food. But for vegetarian people, even check for your parents also. Give them vitamin B12 supplement, because that is very, very important, right? Next is Next, we have vitamin C, right? Now here it is in citrus fruits, right? Orange, lemon, like we have vitamin C, green leafy vegetables. Then vitamin D is like the source is sunlight, fish and egg yolk. So for vegetarians, the only source is sunlight. Vitamin E, vegetable oils like wheat, germ oil, sunflower. So in Indians, though, you will not see the deficiency of vitamin E or vitamin C. You will see the deficiency of vitamin D and vitamin B12, right? So vitamin K is also there in green leafy vegetables like spinach, broccoli. You have good amount of vitamin K, right? Okay. Last part is the hormones, right? So let us see what are these hormones. So hormones are basically very rarely they can ask you question from hormones. Most probably till here though we have completed what they will ask, but hormones just go through that once, right? Hormones, they try to ask question in NEET, right? Not in JEE, right? So I'll just tell you, hormones are molecules that act as intercellular messengers. In our body, we have different hormones, right? That actually sends messages. There is stress hormones, happy hormone, love hormone, all the different hormones that we have. Reproductive hormones, they are produced in endocrine gland in the body and are poured directly in the bloodstream, which transport it to the site of action, right? They help to maintain the balance of biological activities in the body. Whatever we are feeling, right? All things are not your heart, it's because of the hormones, right? Okay, your heart is a very innocent person, it's just pumping, right? It's the hormones who are like your mood swings, everything, stress, everything is related to hormones, right? So these are main hormones in your body. First is insulin, that is produced in the that keeping blood glucose level, right? It is an example of this function. Insulin released in response to rapid rise in the blood glucose level, right? So basically blood glucose level, it depends on the insulin, right? Then you have glucagon, it tends to increase the glucose level in the blood. Then you have epinephrine and norepinephrine hormone. They mediate response to external stimuli, right? For example, we touch a hot thing and a very cold thing. So what will happen? How messages are sent to our brain, right? Then you have growth hormones, right? And sex hormones, they play a role in growth and development of the people, right? Then you have thyroxine hormone, right? It is produced in thyroid gland. It is iodinated derivative of amino acid tyrosine, right? So basically here you will have iodine also. Here you will have iodine also. Abnormally low level of thyroxine leads to hypothyroidism, which is characterized by letharginess and obesity, right? Thyroid, we know now that's okay, this person is very fat because they have thyroid, this person is very thin because of thyroid. So basically this is what they are talking about. Increased level of thyroxine causes hyper, that means very slim, not even slim, it is malnutrition you are, right? So basically when you have more thyroid, now when you have low level of thyroxine, that will lead to obesity, right? You will get really fat because of that. That's why some people, they don't eat anything but they are not able to lose the weight, right? Then steroid hormone, right? So steroids, they are produced in adrenal cortex and gons, that is testes in males and ovaries in females, right? So they are responsible for reproductive health. Hormones released by adrenal cortex play a very important role in function of the body. Basically all this is related to bio only, that will not be asked in your exam, right? But still go through that. The mineral corticoids control the level of exertion of excretion of water and salt by the kidney, right? The adrenal gland is basically stress only. It is adrenaline hormone is also related to stress only, right? So does not function properly, then one of the result may be Addison disease, characterized by hypoglycemia, weakness and increased susceptibility to stress. So basically adrenaline, that we say adrenaline rush, right? That is not good for your body, that is bad for your body, right? So that is not good. Dopamine is good for your body. The disease is fatal unless it is treated by these and these medications that you don't need to remember, right? Now testosterone is a male hormone, right? It is major sex hormone produced in males. It is responsible for development of secondary male characteristics, right? Estradiol, that is a female hormone. It is female sex hormone responsible for development of secondary female characteristics. Progesterone is responsible for preparing the uterus for the pregnancy, right? Preparing the uterus for the implantation of the fertilized egg. So these are all the reproductive hormones that you have, right? So basically from hormones, so they will not ask you question. That is why in a very speed manner I taught you hormone, right? Yes, but from amino acids, carbohydrates, questions like it's high probability of asking questions. Then from DNA and RNA, and maybe some part of vitamins also. Okay. Yes, yeah. Have you seen one one Insta influencer? He was like very famous. He had like million of following. He had those like biceps and all. But now his health has gone really down because of one steroid he has used, right? He also named that steroid in his reel, right? In his Insta reel, he also mentioned that how he because of like not the guidance, because of not having proper guidance, because of just I want to make my body. They were taking steroids and now he had kidney failure, right? So his both kidneys were failed, right? So that is the effect of steroids, right? Okay. Okay. Yes, the haloalkanes I'll teach on Friday, okay? The Friday lecture is going to be haloalkanes, halorines only, right? Now, diabetes, I think it is low insulin. Diabetes is both things, no? It is sugar is high and low, both the things can happen, right? That I forgot. That definitely I'm not a bio teacher, guys, right? Neither I'm a doctor. So I don't know, but I think it is because insulin is injected when you have like diabetes, right? So I think it is because of low insulin, maybe. Not sure about it, right? Okay. Now, two nucleides are joined together by linkage known as. Now, we have previous year question. I want everyone to be active here. Two nucleotides are joined together by linkage known as which one? Phosphodiester, glycosidic, disulfide or peptide. Two nucleotides. Nucleotides are linked by which thing? Which thing? Nucleotides. Peptide, no. Disulfide, glycosidic, which kind of linkage? Which kind of linkage? They are connected. Nucleotides we are talking about. Nucleotides, how they are connected to each other. Peptide is in amino acids. Nucleotides means they are talking about DNA and RNA. DNA and RNA. DNA and RNA. Glycosidic is there in carbohydrates. Carbohydrates. Peptide linkage is there in amino acids. That means in proteins. In proteins you have peptide linkage. Right? So the answer will be yes. Very good. Answer is phosphodiester bond. This also I have shown you that in nucleotides you have phosphoric acid. Right? That is why the phosphoric acid will link with each other. That's how you have that full linkage, that full how these are connected to each other, how one unit is connected to the other unit, right? So answer is phosphodiester bond, right? Next question is, which structure of protein remains intact after coagulation? Now this question I have not taught you. I was waiting for the question here. It's a very important question. Coagulation of egg means denaturation of protein. That means the structure will disrupt. That means the structure will break here. But it will not. Quaternary structure will break. Tertiary will break. Secondary will break. But the primary structure will remain as it is. So primary structure will have no effect here. Which structure remains intact? That is the primary structure will remain intact as it is. Right? Next question here you have. Match list 1 with list 2, right? So you have list 1 and list 2. List 1 you have Ziegler, Natta, Catalyst, right? So this is actually mixed questions, right? Some of them are in other chapters as well as here also. Mostly they are connected to biomolecules only. See, Ziegler-Natta catalyst is connected to which thing, right? Then you have Wilkinson catalyst is connected to which thing? Blood is connected to which thing? Vitamin B and B12 are connected to which thing, right? Okay. So guys, see, Ziegler-Natta catalyst is connected to titanium, right? Wilkinson has rhodium, right? And then blood pigment, it has iron, and vitamin B has vitamin B or B12 has cobalt, right? So A is fourth, B is third, C is 1, and D is 2. So answer will be fourth is the correct answer. Okay, 4 or 1. She was confused in 4 or 1. Okay, no issues, but fourth is the correct answer here, right? Fourth will be the correct answer here, right? So all are theoretical questions only. Next we have the list here. The list here, these are all 2024 questions, okay? Now, match the list 1 with the second list. Here you have starch. Starch is made up of which thing? Starch is made up of alpha glucose or beta? Starch is made up of alpha glucose. So A is second. Cellulose, that is made up of beta glucose. Told you. Beta means third one, right? That is for beta. Starch is for alpha. Cellulose is for beta. Nucleic acids, they are made up of nucleic acid. They have which polymer, which monomer? Nucleotides are connected by phosphodiester bond, right? So it is connected to 1, that is C for nucleotide. Protein, definitely it is alpha amino acid is the monomer, so D is fourth one. So A second, B third, C 1 and D 4. So fourth is the correct answer again, right? Okay. Next question. Next is sugar which does not give reddish brown precipitate will failing the reagent test. I told you all disaccharides are reducing sugar. But there is one disaccharide which is not a reducing sugar. They are talking about the reducing sugar. This is a reducing test. Which is not a reducing sugar? Which is not a reducing? All are reducing, one is not reducing. And that is sucrose. Sucrose is not reducing in nature. So answer is first, that is sucrose is the correct answer here. Right? Okay guys. Next we have, okay, C. Why C? Glucose. No, glucose. It's not even like we can't say. Disaccharides we will talk about whether they are reducing or non-reducing. Right? Okay. Yes. Next is the total number of correct statements regarding the nucleic acids. Right? RNA is regarded as the total number of correct statements they are talking about. RNA is regarded as reserve of genetic information. DNA is self-duplicates during cell division. Okay, DNA synthesizes protein in the cell. The message for synthesis of particular protein is present in DNA. Identical DNA strands are transferred to daughter cells. So, which of the following is the correct statement? How many? The number of correct statement they are asking. Number of correct statement they are asking. Is it? They should have which of the following is the correct statement should be the question. RNA is regarded as reserve of genetic information. It is DNA that is the reserve of genetic information. DNA molecule self-duplicates during the cell division. That is not true. It does not self-duplicate itself, right? It will not self-duplicate itself, right? It will, DNA information is passed to two people, right? DNA synthesizes proteins in the cell. That is true. Then we have cell message for synthesis of particular protein is present in DNA. Not true. Identical DNA strands are transferred to daughter nuclei. That is also not true, right? So answer C is the correct answer. Okay. Okay. Now, next is why they have written correct statements. Next is match the following. Now, this is the question that I was talking about. Right? Now, in this question, you have 1, 2, 3, 4 reactions. This we have done, this we have done, this also I told you. This also I told you. Right? So, try to answer this. I think this so you can answer easily because we have done this today only. Glucose with NaHCO3, what it will do? This was in the like when we talked about closed and open structure. I told you that it will give no reaction, right? Glucose with HNO3, it will a very strong oxidizing agent. It will give saccaric acid, right? That means 2CHO will be converted to COHN and CH2OH is also converted to COH, right? And then glucose with HI, it is going to give us N-hexane. Then you have glucose and bromine water. It is going to give you gluconic acid. So what will be the correct answer? If 2, answer will be second is the correct answer. Okay? Understood? Yes, everybody? Understood? Yes. Okay. Your temperature. Which of the following is correct structure of L-glucose? Now, this is an interesting question, okay? Why? Because L-glucose is actually mirror image of D-glucose, right? It is actually a mirror image. So, how you can identify? L means on the last chiral carbon, OH should be on the left side. This is the last chiral carbon, it is on the left side. Here also it is on the left side, here also on the left side, here it is on the right side. So, definitely this is not the correct answer. Out of these 4, which is the correct answer? Let us see that. Out of these 4, which is the correct answer? I told you it should be opposite. It will be mirror image. So, if you draw the structure of glucose, it will be, this is CHO, this is CH2OH. On the third 1, 2, 3, you should have OH on the left side. Others OH should be on the right side. Right? Okay. Now you want to have the mirror image. Now OH should be on the left side. And here OH should be on the right side. This becomes the mirror image. Now this is H, OH, HH. So first will be the correct answer. So L-glucose you can write here. It is a mirror image of D-glucose. D-glucose. That is your, because that's why they are enantiomers. Right? Okay? Right? Okay. Now, next one is, this also we have done. Next is match the list 1 with the list second. Right? Match list 1 with list second. Okay. This also you can do. Isn't it simple? See, mostly though they are asking the same thing only. It's just that they are giving you match the following, right? This is the criteria. This is a trend that JEE, JEE people follow. They give you match the following so that in one question they can ask you so many questions from there, right? So from here you have alpha glucose, alpha galactose. Alpha glucose and galactose at one position, right? They are different. Right, at one position the configuration is opposite, right? We'll talk about that. Then we have alpha glucose and alpha ribose, alpha glucose and alpha fructose. Then we have, now if you talk about glucose and fructose, right, they are actually having different functional groups, so they are called functional isomers of each other, right? So C will be 1, right? This though we have done. Then glucose alpha and beta, now they are definitely what? Anomers, right? Why they are anomers? Why they are anomers? Because there is change in one position, right? In the first position, so that B is called 3. B is called 3. Now alpha glucose and alpha ribose, and you have C is 1. Where is C is 1? C is 1 and B is 3, right? Already we know the answer, right? Now you have alpha glucose and alpha galactose. Here the position, the difference is in C4 position, right? In C4 position, I told you the difference is in C4 position. Then you have alpha glucose and ribose, right? Okay, alpha glucose and ribose. Now alpha glucose and ribose, they are this I have not shown you, like this I didn't told you, right? But yes, ribose, if you see ribose, it is a pentagonal ring and glucose is a hexagonal ring. So that is why they are homologous of each other, right? So then you have D as second and A as fourth, right? So answer is this, A4, B3, C1, D2, right? Okay, understood? Understood? So A will be the correct answer. A is going to be the correct answer. Next we have coagulation of egg. Again, the question is asked. Coagulation of egg on heating is because of the secondary structure remain unchanged, denaturation of protein, biological property remain unchanged, breaking of peptide linkage in primary structure. This so definitely not. Now I have given you two options, right? Denaturation of protein, I have already told you in one of the question here that denaturation, that means the protein is going to break here. Only primary structure is going to stay as it is, other structures will break, right? Okay. Then you have, this is the structure, this is glucose only, now can be oxidized. This is alpha glucose, not even alpha we can't say because first position we don't have here, right? So this is your glucose, right? This is glucose, right? 1, 2, 3 on the third position, OH is on the left side, so it is glucose, right? It can be oxidized to dicarboxylic acid by Br2. Br2 is a mild oxidizing agent. It cannot be oxidized to dicarboxylic acid. Only one, you will have only convert CHO to COH. So that is a wrong statement. Will coexist in equilibrium with two other cyclic structure? It has two alpha and beta cyclic structures, right? There is one statement or two statement? Incorrect one statement. Okay, will coexist with two other cyclic structures. They are telling you the incorrect statement regarding the given structure is. First is incorrect, second is correct. Despite the presence of CHO does not have Schiff's test. Yes, because of cyclic structure. This also we have done, cyclic structure, right? This also, very good. It has 4 asymmetric carbon, 4 chiral carbon. I told you that it has 4 chiral carbon, right? So answer means this is the incorrect. Incorrect they asked you, right? So first is the incorrect statement, okay? First is the incorrect statement that you have here. Okay, next is JEE advanced questions, right? So advanced is also easy only. If you see, advanced is also not difficult here, right? So now this is the structure they are giving you. I'm just giving you an idea what they are asking. The disaccharide X cannot be oxidized to bromine water. It cannot be oxidized by bromine water. The acid hydrolysis of X leads to levorotatory rotation. This is the point where you can tell they are talking about disaccharides and what disaccharides they are talking about. A disaccharides which cannot be oxidized by bromine water. That means it is non-reducing. This is the first hint they have given you, which cannot be oxidized. The acid hydrolysis of X. See, if it is non-reducing, it itself does not want to get oxidized, right? So, acid hydrolysis of X leads to levorotatory rotation. Levorotatory. I told you which is called levorotatory. What is the name of that disaccharides? Which is converted to levorotatory after hydrolysis. I told you there is one invert sugar. That is called invert sugar, which itself is dextro, but after hydrolysis, it is converted to levo. Why? Because sucrose, the answer is sucrose, after hydrolysis will get glucose and fructose. Glucose is dextro, this is levo, this is dextro, but the fructose levorotration is more. That is why sucrose is the answer. Sucrose is made up of which thing? Anybody? Now that is why this is, firstly you have to identify what they are talking about. Then you need to tell the structure. Sucrose will be made up of alpha glucose and beta fructose. Can you tell me the linkage? Anybody in the chat box? The linkage is C1C4, C1C2 linkage. C1C2 linkage, right? So can you see here where you have C1C2 linkage? Where you have C1C2 linkage? Where you have C1C2 linkage? So here you will have C1C2 linkage, no? Alpha. Firstly, so you need to understand where you have alpha glucose and where what you have what. Like here you have C4. This is your C4, right? This is C2 you need to have, no? You need to have one fructose. So this cannot be the answer. This cannot say directly given. This cannot be the answer. The answer can be this only because here you have glucose, here this is fructose. So answer is this one. This is the answer. Okay? So this will be the answer. Okay? B beta, B, wait a minute. Oh, I forgot to see that B is also fructose. Wait a minute, this is fructose, this is glucose. Glucose has started from this side 1, 2, 3, 4, 5. 5 linkage and this is fructose is 1, 2, 3, 4, 5. This is actually 5 and 1 linkage. I need 1 and 2 linkage. I need 1 linkage of glucose. So it is 1, 2, 3, 4, 5 and this is 6. And this is I need second linkage here. So it is 1, 2, 3, 4, 5, 6. Right, so it is 1, 2 linkage. So first will be the correct answer. Okay, linkages also you need to see which linkage they are talking about. Okay, so 1 is the correct answer. A is the correct answer. Okay, understood? Next is, A is the correct answer. Which of the following statements are true? Oxidation of glucose with bromine water. It was so many times they have asked the same question. Oxidation of glucose with bromine water will give glutamic acid. That is, wait a minute, which is the following statement? Glutamic acid. Glutamic acid it will not give. It will give glutonic acid. Gluconic acid it will give. That will not be the correct answer. The two 6-membered cyclic hemiacetals form 2 6-membered cyclic hemiacetals. Of this are called anomers. That means they are talking about alpha and beta. This is true. See here, multiple answers can be there. Multiple answers can be there, right? Hydrolysis of sucrose give dextrorotatory glucose and levorotatory fructose. Yes, this is also true. Monosaccharides cannot be hydrolyzed to give polyhydroxyaldehyde or this. That is also true. Monosaccharides will not, glucose will not give more glucose units, right? So these are the 3 correct answers. This is the wrong statement. Okay. So answer is, they are asking you which of the following is correct. No. So the A, B and B, C and D are correct. Multiple answers. Okay. Multiple answers are also asked. Okay. Understood? Okay guys. How many questions are left? 2 questions are left. Okay. So the Fischer presentation of D-glucose is given by which thing? So you have D-glucose. Yes, they are saying the correct structure of beta L glucopyranose. Means glucose only. They are saying pyranose. Essay they have written. Why? Because it is a pyranose ring, right? So here you need to have beta L. Beta L. Firstly, it should be beta. Firstly, it should be L. L means mirror image. Make the mirror image of this thing. Mirror image of this thing is going to be 1, 2, 3, 4. It is going to be H, OH, H, and this is H. This is OH. This is OH. This is H, and this is OH. This is your L, and this is L, but this is alpha only. This is alpha only. Right? So if you want to make beta here, then on the first position, right? See, very simple thing. This will be your first, this will be second, this will be third, fourth, fifth, sixth. Firstly, forget about fifth. Just think about the first one, right? From here, how you will make the cyclic structure. Direct way. How you will make the cyclic structure here. This will be your first, second, third, fourth, and this is fifth. Obviously, on fifth carbon, you will have CH2OH and H here, right? That is so definitely. On the first, if they are saying beta, that means OH should be on the left side. Left means it should be upwards. So it should be upwards. Rest of the things will remain same. On the second position, you have H on the right side means downwards. Then you have OH here. Then you have H again here, right? So this is going to be the answer. This is going to be the answer. Let us see. It matches with which thing? This is OH, OH, HOH, OHH. This is the wrong one because of this thing. OHH, OHH. This is also because of this thing it is wrong. Here it is OHH, HOH, HOH. This is also wrong. It's not 2 here. It's second carbon. I'll just write it here. And this is OH. Okay. This is HOH. Wait a minute, yaar. Why I'm not getting even one single correct answer here? Beta glucose, na, you're talking about. Wait a minute. Beta means on the first carbon, it should be on the left side. That means upwards. Right? Then you have all on the right side. All which are on the right side. Right? That means H, right side means downwards. Then again downwards. Then H downwards. Right, so it should be HOH, OHH, HOH, OHH. I'm not getting even a single answer as the correct one. Just give me a second. The Fischer representation of D-glucose. Wait a minute, guys. Why we are not getting any structure as the correct one? They are saying this is the correct one. Okay. Okay, I'll just mark this as question mark because I'm not getting any of the structure as the correct one, right? So I'll just mark this as question mark and I'll see, right? Okay. Okay. Okay, just mark this as question mark. I'll see what is it because you have D is the opposite. It is a mirror image. H, H here, OH and OH. Now after making the cyclic structure, OH on the first carbon, if it is beta, that should be upwards, right? Beta should be on the left side. Left means it should be upwards. But they have marked this as the correct one, right? So that is my big doubt, right? Beta L they are saying, no? So let's mark it as question mark, right? Okay. So that is, let's mark it as question mark because I still have doubt on this, that how come this is the correct answer. Okay, I'll just verify this thing here. I'll see if there is any typing mistake or maybe any mistake can be there. Okay, yes. Okay, chalo. Now, that's it for today. I think that was not the last question. There is one more question here, right? So they have given you the structure of D positive glucose and what they are asking you, the structure of L glucose. Right, so L-glucose is, as we know, that is a mirror image, right? So mirror image will be CH2OH on the right side, OH on the left side, then H on the left side, then OH, then OH. So this is going to be the L-glucose. That is going to be opposite here, right? Okay. Okay. So that is going to be the L-glucose. That is going to be the opposite here. So this is going to be the correct answer. Right? Okay. And here it should be positive. right? Okay, chalo. So that was the last question of today, and that's it for today. And we have completed biomolecules. Now on your, is this advanced? Very easy. Yeah, that was advanced. I was also like amazed to see that, right? Maybe, right? Now, guys, we have completed biomolecules also. We are left with the, like, we have completed like everything that you are, like, all the chapters that I saw in the playlist that were not there in the playlist. I have completed those chapters. Now, because of your special request, I'm going to do haloalkanes and haloarenes on Friday, right? Okay, I'm going to do haloalkanes and haloarenes on Friday. And I hope so you guys will be there, because I can see the live watching is very, very disappointing, right? So I don't know why you guys don't want to study. Maybe you guys are self studying, or maybe you just want to see the questions. So let me know in the comment section what actually you want from this side, right? Okay, chalo. Okay, beta, bye bye. Take care. See you all in the next class. Bye bye.